Techaholic was conceptualized in mid-2018 as an open community platform. Techaholic connects industry professionals, vertical experts, and learners together, bringing real-world relevance and career exposure for enhanced learning. Our vision is to enable professionals and organizations to achieve more through the community collaboration. Our mission is to nurture industry-ready professionals who can enhance nosiness outcomes with skills on upcoming technology landscape. And our values are to make everyone shine by sharing our knowledge, bringing honor to individuals, encouraging innovation by using the latest technology, networking to enhance collaboration, and encouraging excellence in technology-enabled solutions. We are creating communities with the motto of Go Far, Go Together. We empower individuals to achieve more through their skills without worrying about anything else. We help our community members to become industry-renowned, self-dependent professionals. To achieve industry recognitions, you can join our community to work with our existing industry-renowned community leaders. Our community leaders could mentor you and provide the stage to work with local and global communities. Mentors can lead you to the next level of growth. Techaholic empowers individuals to achieve their career aspirations by connecting them with the right mentors who are proven industry veterans and subject matter experts. Internships help you with real-world experience. Today's students are tomorrow's leaders, so we will not leave you alone. We have open internship programs to onboard technology enthusiastic students through formal process. Lead your digital transformation assisted by our industry veterans and technology community experts. Our designs are centered around business and technical requirements. We optimize your cloud designs to enhance administration and user experience. We secure your cloud with defense in depth. We provide guidance on cloud governance and compliance. Techaholic can also help you solve problems like lack of flexibility in capacity and cost optimizations, time to execute, efficient remote working, and infrastructure monitoring. Techaholic is making it easier for both freelancers and organizations by inventing a new way of working with freelancers globally. As a freelancer, you can choose your assignments either through your own network or through our network. We take care of all the onboarding tasks so that you only focus on your assignment. We are continuously growing our community to help individuals and organizations in capability building with skill-based learning. In the ever-changing job roles, we are extending the learning outreach by nurturing the future-ready and most desired professionals in the industry. We bring together a large array of technology professionals with varied industrial accreditations, eager to help build enterprise solutions and enable the learners. Now let's look at some of the popular industry certification courses offered by Techaholic.
Hello, everyone. Can you see me? Perfect. I think you can hear me. I'm not sure can you see me yet or not, but very much a welcome on my part to this session. Perfect, perfect. So let's get started. I'm getting in the okay from the tech side that everything should be working as is. Um, Welcome everyone to the second day of the great conference. I'm really excited to be talking today as well. So let's get started as we don't have too much time to waste. So I will start sharing my screen. I think I am sharing at the moment. Yes, you can probably see it now. Perfect. So I will go into slide presentation mode soon as well. So we can get this session on and let's kick it off. So let's see. There we go. I think you can see the screen very well. Let's do a final check. Yes, it looks good. Perfect. So yeah, very much big welcome on my part as well. Welcome to Kubernetes in the Cloud Zero to Hero session. Super happy to be here. Happy to be talking to you today as well. And then let's kick it off. So, what value do you get by attending this talk, this session? So, as the title says, it's Kubernetes in the cloud. So Kubernetes is really big. It's kind of the de facto container management platform at the moment, the container orchestration platform. Really great things happening on this scene. So this session really is a zero to hero session. This is not exactly, I built the session to be not to be completely like a beginner get started session. It's more of an how to use, if you're thinking about using or you're really starting to use Kubernetes in the cloud, how to get the most out of your experience. So what are the shortcuts you should be taking, how to get started, what are some best practices that you should be looking into, all of these things. I will not be going through any kind of super kind of detailed, okay, do this and input this into your command line and everything, all these kind of things, because I think these are best to take your own time and to focus on them. So if you are really wanting to, I think this session is a great start to kick off, and from there is to find your own best match for, let's say, the best step-by-step guide, and then follow along with that as you do your own first clusters and everything. um, but I hope this session can give you a bit of an overview on what are the things that you should be looking into and what you should be considering while you're doing this, taking this journey. I will be focusing on AWS and Azure in this session the most. Doing a bit more focus on AWS in this session as well, but Azure will be alongside that as well. There's obviously other Kubernetes managed services and other ways to connect to Kubernetes as well out there. All of them really great. All of them have really great size, as well as obviously every service and product has their challenges. But those are the two that I will focusing on, which is AWS as well as Azure today. So before we kick off with the content side of things, I am Annie. Nice to meet you all. This virtually conference way. So I am a CNCF ambassador and a product marketing manager at Cast AI, and Cast AI does Kubernetes cost optimization. So we're a Kubernetes optimization platform. So I do Kubernetes as at work, as well as I do these kind of amazing conferences whenever I can as well. I am also a Kubernetes and CNCF meetup co-organizer, as well as a startup coach. I am a co-host of Cloud Gossip podcast, which you can find at cloudgossip.net. If you want to find out more about the cloud, we interview top industry professionals and so forth. Really great stuff there. Then a bit of expectation management. I went through a bit of this as well. So as I said, mentioned this session will focus on AWS as well as Azure on the side. But these lessons apply to other cloud providers as well. Really, the Kubernetes managed services have a lot of similarities across all the clouds, but there's something you have to focus, something you have to write, something to your slide. So AWS is one of the focuses here, but the lessons learned really apply overall as well. So no worries, even if you are an Azure user or Google Cloud user or anything, these lessons will benefit you as well. So I've structured the session show that we start with kind of discovering what are the major differences between a few of the possible ways to use Kubernetes on major cloud providers. So differences between managed services essentially from cloud providers for managing Kubernetes in the cloud. And from there, I will be going through a bit of a best practices on what to consider when you're doing Kubernetes in the cloud. As well as then after that, I will be taking you through how to use Helm to really supercharge, to boost your Kubernetes in the cloud journey, as well as also, actually in the middle of this, I will also show you how to use EKS to create your first Kubernetes cluster, as well as an easier way to do it both in Azure as well as in AKS or EKS as well in the middle there as well, and hopefully wrapping it up all nicely in the end with a nice wrap up, as well as great learn more resources, so you can continue your Kubernetes in the cloud journey on your own as well. So kicking it off with a slide that's very AWS focused. So Kubernetes on AWS, you have few examples, for example, you can use to get to Kubernetes. So you have EKS or ECS or Fargate, for example. So these map really kind of, nothing obviously match one-to-one. It's never exactly comparing apples to apples. But for example, EKS is, well, it's pretty similar to AKS. So Elastic Kubernetes Service is really similar to Azure Kubernetes Service. And then ECS, which is one of the major things that I'm comparing here, EKS and ECS. ECS is really similar to Azure Container Instance, so ACI. So these things, the parallels that you can draw between the two services are really similar. There's obviously always some details here and there, but we can learn a lot with these as well. So anytime I say EKS, you can imagine also AKS, or you can, if I say ECS, you can imagine Azure Container Instance as well. Not exact match, but close enough that we can get a lot of learnings out of this session this way. And why am I comparing the few different services here, and why does it matter for this session? I think it's really important to understand, okay, how can you use Kubernetes in the cloud the best way, as well as how does the platform or the service that you choose in the beginning, how does it affect your Kubernetes journey going along from there? So how does it impact going forward into your journey within it, and what does, because you're making a decision in the beginning, but how does that impact actually long term, what you can do and what you cannot do within your Kubernetes environment. So that's it has a surprisingly long tail, this decision. So that's why I think it's super important to go through things, as well as the fact that through this we will actually learn more about what these services mean and what do they actually mean in the practical sense for, and what are the different features and everything within these services. So AWS Elastic Kubernetes Service, which is really similar to AKS as well. So EKS is a service that provides and manages Kubernetes control plane on its own. You have no access to the master nodes on EKS since they are under management of the cloud provider. So to run a Kubernetes workload, EKS establishes a control plane and Kubernetes API in your managed AWS infrastructure, and then you're really good to go. So at this point, you can deploy workloads using Kubernetes native tools like kubectl, Kubernetes Dashboard, Helm, Terraform, all of these things. So really the advantages of using, for example, AWS EKS or AKS as well, is that you don't have to install, operate, and maintain your own Kubernetes control plane. EKS allows you to easily run tooling and plugins developed by the Kubernetes open source community. And then EKS automates load distribution and parallel processing between any DevOps engineer, better than really any DevOps engineering could, even though DevOps engineers are really amazing. But there is some things that automation and all of these things do really well. And your Kubernetes assets integrate seamlessly with AWS services if you use EKS. So EKS uses VPC networking, and any application running on EKS is compatible with one running in your existing Kubernetes environment. And you can migrate to EKS without applying any changes to the code, and it works really nicely. So these and the challenges are deployment requires expert configuration. Pick it if you're ready to handle the scalability level of Kubernetes. So here, as mentioned before, AKS has a lot of the similar things. So you can also use all of the Azure cloud features if you're using AKS, but also with AKS, you can use a lot of the community minded tooling as well, which is one of the greatest pros of EKS as well. So with AWS Elastic Container Service, which is ECS, which is comparable to Azure Container Instance as well. So you can, AWS ECS stands for AWS Elastic Container Service. It's a scalable container orchestration platform. And it was designed to run, stop, and manage containers in a cluster. The containers themselves are defined here as part of a task definitions and driven by ECS in the cloud. So you can use ECS with EC2 instances. So best for really long running tasks, or you can use it also with AWS Fargate. So good for serverless tasks on there. If we then take a closer look at these two options, which is ECS with EC2 instances. So in this model, containers are deployed to EC2 instances, which is VMs, created for the cluster, and ECS manages them together with tasks that are part of the task definition. So the pros really here are that you have full control over the type of EC2 instance used here. So you can use a GPU optimized instance type if you need to run a training for a machine learning model that comes with unique GPU requirements, for example. And you can use spot instances, for example, as well. So the cons really are that you're responsible for security patches and network security for the instances, as well as their scalability in the cluster. But you can use Kubernetes auto-scaling for that, and I will be talking about that a bit later as well. So in Fargate variant, you don't need to worry about EC2 instances or servers anymore. So you just have to choose CPU and memory combo. You need your containers to be deployed there. So the pros are really no servers to manage. The cloud provider is in charge of the container availability and the scalability. Still, it's better to select the right CPU and memory, otherwise you might risk your application becoming unavailable as well. So you can use Fargate Spot, a new capability that can run interruption tolerant ECS tasks up to a 70% discount off the Fargate price, which is really nice as well. And the cons is that ECS plus Fargate supports only one networking mode, which is AWS VPC, which limits your control over the networking layer there. And then let's do a check there. Good. And then let's move on to the next slide. So if you're gonna think about using AWS Fargate, which then goes more into serverless tooling, so AWS Fargate is really about in a way that, usually a container management platform reworks a server's CPU and memory to allocate them to your workloads better. But really the underlying server is still there, just divided in a different way. And it might become a burden in managing your systems. So AWS solves this problem with Fargate by taking over the management of that underlying server. So instead of doing all the tasks yourselves, from booting the server and installing the agent to making sure that it's up to date, you can simply create a cluster and add your workload to it. So AWS will add pre-configured servers. I'm having a tongue twister moment here for sure. Servers to the pool automatically support your requirements. I think pre-configured, I must add it to the list of tongue twisters that I can use. So really, today, 32% of AWS containers run on Fargate as well. So if you are considering Fargate or a similar service, So here's a few things that you should consider before jumping into the Fargate bandwagon. It's not a good fit for highly regulated environments where companies use dedicated tenancy hosting. And the combination of ECS and Fargate supports only one networking mode, AWS VPC, that comes with limitations if you need to have a deep control over the networking layer. And Fargate allocates resources automatically, but you can set a few controls over how it works. So this can really easily lead to uncontrolled cost rise if you fail to closely monitor the pricing, for example. So that's for that one. So then when we think about EKS and ECS similarities, they really both have a layer of abstraction. EKS and ECS comes with a layer of abstraction for containers and called deployments for EKS and tasks for ECS. Their functionalities are quite similar. Both ECS and EKS have an abstraction called a cluster and a combination of all the working components. So they also allow a mix of AWS compute platforms. So whether you're running your containers with ECS and EKS, you can choose one or more AWS compute options from EC2 instances, AWS Fargate, AWS Outpost, AWS Local Zones, AWS Wavelength, or any of these. You can choose what you want to use. And you don't need to monitor or operate them. So managed services is what this means. So they eliminate the effort in operating services and allow your teams to focus on core applications. So you can easily assume that they are reliable and highly available at all times. The Kubernetes control plane and API will be up and running no matter what, even when updating the latest release. And naturally, this also happens automatically as well. And they really do share an approach to security. So to access services and resources securely, the cloud provider provides an identity and access management solution, so you can create users and user groups and then assign permissions to them. This control system is available in both ECS and EKS. For example, you can use IAM to limit who can access ECS tasks and Kubernetes workflows. And in Azure world, it would be about Azure AD and Azure kind of rolling and all of these things. So a lot of these services, they are very closely mapped with AKS and EKS, as well as ECS and the Azure Container Instance as well. So what are the differences then between these kind of services? What's the difference between EKS and ECS in this case? So one of the differences is pricing. In general, if you run ECS and EKS clusters in EC2 instances, you'll be paying the compute costs that depend on the instance types you pick and its running time. So ECS doesn't come with any additional charges, but EKS does. But it is all manageable, and it is a bit of a difference, but you can still manage it. I will be giving a bit of cost optimization tips towards the middle part of the presentation as well, so no worries there. So the second difference is deployment. You can set up both EKS and ECS from the AWS management console, but then things start looking different. ECS is really simple to deploy. After all, it was designed to be a simple API for creating containerized workloads without any complex abstractions. You get no control plane, so once your cluster is set up, you can configure and deploy tasks directly from the AWS management console. And deploying clusters in EKS is a bit more complex and requires expert configuration. You need to configure and deploy pods via Kubernetes first, because EKS is just another layer for creating Kubernetes clusters in AWS. So you need to have more expertise and operational knowledge to deploy and manage applications on EKS when compared to ECS, for example. Then the third one is really multi-cloud portability. So the ideal scenario is when you can move your workloads from one cloud provider to another with minimal disruption. So this is what the portability is all about. So to achieve it, you need interoperability among cloud services. So this is a big difference, and this applies relatively similarly between AKS and Azure Container Instance as it does between EKS and ECS. So while ECS is an AWS proprietary technology, EKS is based on Kubernetes, which is open source. So Kubernetes in EKS allows you to package your containers and move them to another platform quickly. So ECS might lock you in more. So if you build your application in ECS, you're likely to really encounter a vendor lock-in. So in the long run, but if you choose to design your application on Kubernetes, you can basically run it on any other Kubernetes cluster from own clouds to premises. So this applies to EKS or AKS, for example. So the fourth difference is networking. So when using ECS, you use AWS VPC network that receives an elastic network interface attached to the container instance hosting it. And you'll be looking at default limits to the number of network interfaces that can be attached to the EC2 instance. So just to give you an idea, a C5 large instance may have up to 4 NIIs attached to it by default as well. So in ECS, the maximum number of NIIs you can assign varies by the EC2 type. So even though AWS increased the limits, this might not be enough to support all of the containers you want running in this particular instance as well. With EKS, you can assign a dedicated network interface to a pod to improve security, and all of the containers inside that pod will share an internal network and public IP. And the fifth one, which is a really big point for me, is community support. So the open source Kubernetes rules over proprietary ECS here for sure. And this same more or less applies to AKS as well as Azure Container Instance. So the AKS approach, so the more Kubernetes, pure Kubernetes approach, really gives you a lot of options. So you can community support from Stack Overflow to GitHub issues to resources, as well as community maintainer tools such as kubectl, extensions, Helm charts, Kubernetes operators, all of these things. So these bring a lot more value into your Kubernetes cloud environment as well. So just as a quick rundown through when to choose EKS. So when you need a granular control over container placement, or when you need more networking modes, and when you want more control over your tooling. And ECS when your DevOps resources are limited, and when you don't have the time or resources to pick and choose add-ons, and when Kubernetes might just be too much and you just need something super simple and you don't worry about the vendor locking or the potentially really powerful add-ons in the future from the open source community side. Then just a quickly kind of then get you through, okay, Kubernetes in the cloud, how does it look like creating as far as the kind of behind the scenes steps when you're creating the cluster? How does it look like? What are the steps that you need to take? And then also an easier way to do all of these things as well, because particularly in EKS, it is rather not time consuming, not difficult per se, but it's a bit more complex than in some of the clouds, as well as in some of the other managed Kubernetes services. But it also tells you kind of what's happening behind the scene, even though you would have an easier way to do it, which is what I'm going to present at the end. But still, going through the theory is really nice as well. So to create a cluster in EKS, it works as setup, or the first step. There's 3 steps. So the first step is kind of setup or preparation step. So you need to have an AWS account or Azure account or anything of these if you're doing Azure or any of the other cloud providers. You need to, so a free tier, for example, works fine for AWS. So you need to create a VPC, which is a virtual private space in AWS where you can do your own stuff. And you need to create an IAM role with security group. So IAM role really just means create an AWS user, as well as security group means with a list of permissions. And then how to create a cluster in EKS part 2. So the second part of this is to create a cluster control plane. So this is created with the IAM role. So you need to choose cluster name, Kubernetes version, choose region and VPC for your cluster, and set security for your cluster as well. And then third one is create a worker nodes and connect to the cluster. So you have to create as a node group, so group of nodes, choose cluster it will attach to, define security group, select instance type, resources, and define max and min number of nodes as well there. So just as an overview of what all of these were, so step 1, step 2, step 3. And after these, you would have a running Kubernetes cluster and AWS EKS. And this is, well, it doesn't seem too much, but it is a bit more complicated than with some of the tooling, for example, which is Ocean. I think Linode and Azure is quite a lot simpler than EKS as well. But it is very popular, and I think understanding the underlying principles is nice. But there is a simpler way to do it both for EKS and a really simple way for it to do it within Azure as well. So easier way to do it. So you can use EKCTL, CloudFormation, Terraform. So for EKS, I really recommend using EKSCTL, which is the official CLI tool for Amazon EKS. It's an open source tool managed by, well, sponsored by WeWorks that will create a cluster with the default parameters. It will be used an auto-generated name. It will create 5 large worker nodes, which is a really common instance type that can be used for a lot of places. It uses official AWS EKS MII, US West 2 region, and a dedicated VPC as well. And you can customize your cluster by using a config file. And there's actually a really similar kind of tooling already inbuilt to Azure AKS. So for Azure, it is very similarly named. So it's AKS create cluster, which is essentially the same for Azure. So it's actually quite a lot easier to use there. But still, nevertheless, I think it's super nice to understand that, okay, this is the previously things that I mentioned happen in the background, and then you can actually speed up your development by using this kind of really great commands and tooling, either from the cloud providers themselves or from the open source community that really help you continue on your journey further. And then Kubernetes on the cloud, best practices. I will be going through security, reliability, scaling, and cost optimization. I could spend probably hours and hours just explaining a lot of different things about all of these topics. You could do a session on all of these, or just workshops, days of content. So this will be more of a glimpse, or more of a brief overlook into what is possible maybe with these areas, a few tips and tricks here and there, so that you can then deep dive into more of the topics that fit more to your organizational / development needs that you need on your own. Then let's start there. So best practice for security. Number 1 is don't use service account token for authentication. Number 2, employ least privileged access to cloud resources. Number 3, use AWS IAM or Azure AD authentication when multiple users need identical access to the cluster. So make the EKS cluster endpoint private or the AKS private cluster, and regularly audit access to the cluster. So what do all of these actually mean? So don't use a service account token for authentication. It's really about a service account token is a long-lived static credential. If it's compromised, lost, or stolen, an attacker may be able to perform all the actions associated with that token until the service account is deleted. At times, you may need to grant an exception for applications that have to consume the Kubernetes API from the outside the cluster, for example, CI/CD pipeline application. So if such applications need to run on the infrastructure, like in AWS EC2 instances, consider using an instance profile and mapping that to the Kubernetes or BCA role in the AWS alt config map instead. The second one, employ least privileged access to AWS resources, or all of these cloud resources as well. So an AIM user does not need to be assigned privileges to resources to access the Kubernetes API. So if you need to grant user access to your EKS or AKS cluster, create an entry in the AWS, in this case, config map for that user that maps to the specific Kubernetes or RBAC group as well. So then you should use AWS or IAM or Azure AD authentication when multiple users need identical access to the cluster. So rather than creating an entry for each individual user, allow those users to assume a role and map that role to the Kubernetes RBCA group, which will be easier to maintain, especially as the number of users that require access grows. So really, then the next one is make the cluster endpoint private. So by default, when you provision, for example, an EKS cluster, the API cluster endpoint is set to public. meaning it can be accessed from the internet. So despite being accessible from the internet, the endpoint is still considered secure because it still requires all API requests to be authenticated by IAM and then authorized by the Kubernetes RBAC. That said, if your corporate security policy mandates that you restrict access to the API in the internet, you can do a lot of easy hacks there. And you can configure things and make sure that it runs smoothly at the same time. And the last one on this list, regularly audit access to the cluster. So who requires access is likely to change over time. So plan to periodically audit the roles as well as the accesses within the cluster to see who has been granted access and the rights that they've been assigned. You can also use open source tooling such as kubectl who can, for example, to examine the roles bound to a particular service account, user, or group. So there's a lot of open source tooling here as well that you can use to your advantage. Let's do a check. Yeah, so best practices for reliability then. There's a lot of great tips for this one as well. So number one, avoid running singleton pods. And then 2, run multiple replicas. 3, schedule replicas across nodes. And 4, run a Kubernetes metrics server. 5th, which is a bit different one, but I think it's super, super important as well. Well, not important, maybe interesting and good to do as well, is practice chaos engineering. And 6, use a service mesh. So what does these mean actually? If your entire application runs in a single pod, then your application will be unavailable if that pod gets terminated. So instead of deploying applications using individual pods, so you can create deployments. If a pod that is created by the deployment fails or gets terminated, the deployment controller will start a new pod to ensure the specified number of replica pods are always running. So running multiple replicas of pods of an app using deployment helps it run in a highly available manner. So if one replica fails, the remaining replicas will still function, albeit at a reduced capacity, until the Kubernetes creates another pod to make up for the loss. You can use horizontal pod autoscaler as well to scale replicas automatically based on your workload demand. Then 3, schedule replicas across nodes. So running multiple replicas won't be very useful if all the replicas are running in the same node and the node becomes available. So consider using a bot anti-affinity to spread replicas of deployment across multiple worker nodes. And then run a Kubernetes metric server. So you can use Kubernetes metric server to help scale your applications. It is really nice, and it really helps you with the metrics that are collected within your cluster. I highly recommend practicing chaos engineering as well. It's a discipline of experimenting on distributed system in order to build confidence in the system's capability to really withstand turbulent conditions in production. So it's more of a methodology in how to look at your development, but it's really helping you to think about, okay, what are the different scenarios that can happen, and think about it. Okay, it's not like it's not always the perfect moment. So then you have to prepare for any available potential scenario that might happen. And the 6th tip here is use a service mesh. So you can use a service mesh to improve your application's resiliency. So service meshes enable service-to-service communication and increase the observability of your microservices network. So most service mesh products work by having a small network proxy run alongside each service that intercepts and inspects the application's network traffic. Service meshes are, for example, Linkerd, Istio, Kuma, a lot of different ones that you can find. And they give you a lot of, for example, golden service metrics, for example, latency, success rates, all of these things, and they really provide a lot of look into your clusters as well. Then continuing to best practices for scaling. So the Kubernetes autoscaler by SIG or Tech autoscaling is really great. It's a popular cluster autoscaling solution maintained by the SIG, as I said. So it's an open source solution underneath the Kubernetes umbrella. And it's responsible for ensuring that your cluster has enough nodes to schedule your pods without wasting resources. It watches for pods that fail to schedule and for nodes that are under scrutinized. It then simulates the addition or removal of nodes before applying the change to your cluster. So that's really nice. There's also event-driven auto-scaling from Kada, for example. That's really great. It's a very great CNCF project as well that you can use. Let me get some more water so we can then continue with best practices for cost optimization, on the other hand. They are, number one, define your requirements. Choose the right instance types. Number three, verify storage transfer limitations. Four, which could kind of be split into multiple points, but it's essentially kind of like one big area of use AWS Spot instances or Azure Spot VMs. And five, use mixed instances. And six, use automation tools to automate potentially all of this. So really, when you're thinking about cost optimization, you should start as number one point mentions, you should define your requirements. So you should only order what your workload needs across your compute dimensions, from CPU account to an architecture to memory, storage, and network. An affordable instance might really look tempting, but what happens if you start running a memory-intensive application and you end up with a performance issue affecting your brand or customers? It's not a really good place to be. So you really have to pay attention when choosing between CPU and GPU instances. So number two, there's so many instance types. For example, AWS offers more than 150 different instance types. So picking the right type can go quite a long way in helping with your cloud cost optimization. So cloud providers offer many different instance types, matching various use cases with different CPU combinations, memory storage, and networking capacity. So you can scale your resources properly. Cloud providers roll out different computers for their virtual machines, VMs, and the chips in these computers have different performance characteristics. So you might pick an instance type with more performance than you need without even knowing it. So you can do check and benchmark all of the different instance types, and that's obviously the best way to see these. But and it's done by dropping the same workload on each machine type and checking its performance from there. But that will be very time consuming. But there are people who have done it, companies who have done it, so you can find out those guides online as well. Well, then the third one, which is verify storage transfer limitations. So it's worth your time to work on a data storage as part of your cloud cost optimization efforts. Each application comes with a unique storage needs. Make sure that the VM you pick can maintain the storage you need throughout both your workload. So avoid expensive drive options like premium solid state drives unless you plan to use them to your fullest. And then really all about Spot instances or Azure Spot VMs. The first thing when you're considering using them, you should check if your workload is actually Spot ready. So these are a great way to save on your Kubernetes bill. So before jumping into the Spot space, you really need to decide and build your framework. How will you use them? So here are a few questions that you should think about before going with the Spot instances. So how much time does your workload need to finish the job? Is it mission and time critical? Can you handle interruptions? Is it tightly coupled with instance nodes? What tools are you going to use to move your workload when your cloud provider pulls the plug? And these are just a few beginning questions that you should start with. And after that, you have to really cherry pick your Spot instances. So after you pick your instance, check its interruption frequency at the rate at which the instance claimed capacity during the trailing month. So for example, for the AWS, there's an instance advisor covers a wide range of intervals. So there's a lot of things that you can see. And then when you are done with these kind of parameters that you want to do, you have to bid your price on the spot. So once you find the right instance, then it's a good time to set the maximum price you are ready to pay for it. The instance will only run on the marketplace price below or equal to your bid. So here's a really good rule of thumb. Set the maximum price to the one that equals on the on-demand price. So otherwise you risk getting your workload interrupted once the price goes higher than what you have set. So that works really nice. And then the seventh one, which is use mixed instances, which is something really focused on Kubernetes. So it's only specific to Kubernetes use cases. Only a mixed instance strategy gets you the great availability and performance at a reasonable cloud cost, really. So you can pick different instance types. Some are cheaper and good enough, but might not be suitable for high throughput and low latency workload. Depending on your workload, you can often pick the cheapest machine and make it work, or you could have a smaller number of machines with higher specs. So that works really well. So then 8, you can make regions work for you. Actually, not 8. That's a previous note that I had. But in addition to that, you can make regions works for you, so you can use multiple regions to really help with your availability as well. And the last point here is automation tools. For example, Cast AI or other automation tools can automate all of these for you, so you don't have to worry about it. But that's, automation in general is really nice, and I highly recommend using it if you can and if that's possible for you, because then you can actually focus on what you want to spend your time on, not managing the infrastructure of it. So then how to use Kubernetes effectively, really how to get the most out of it. For example, using Helm. So this is Helm is an open source tool that's under the CNCF umbrella, which is Cloud Native Computing Foundation, which manages Kubernetes as well. So these are the type of tools that I mentioned in the beginning that you can use with EKS and AKS, but you can't use with ECS or Azure Container Instance, for example. So these are the things that give you the extra boost and supercharge your Kubernetes clusters as well. So let's run through what is Helm and then a quick Helm demo as well. So Helm is a package manager for Kubernetes. It's like Homebrew, Snap, or Chocolatey for Kubernetes. And Helm maintainer really said as well. So Helm is really package management. So tooling that enables someone who has knowledge of an application and a platform to package up an application so that someone else who has neither extensive knowledge of the application or the way that it needs to be run on the platform, so that they can use it. So this is really the power of package management and the power of Helm. So you can use something that you don't really know truly too deeply about, but you can actually really get it started and really get it started easy. So the benefits of Helm are really that it manages complexity. It has really easy updates. It has really simple and nice sharing, and it has really easy rollback. So you can roll back to older version as well. So Helm is built on a few principles, which are that Helm takes security very seriously, and it can be recommended for public deployment. It's very mature. It's a very graduated project. It has multiple maintainers, multiple companies backing it. It has power user email list, release candidates, all the fun things, all the good things. And it supports Mac, Linux, Windows, and it passed 1 million downloads a month already in 2019. So Helm is used by using charts and what are the prerequisites, a Kubernetes cluster, and deciding what security configurations to apply to your installation, if any, and installing and configuring Helm after that. So as a quick demo towards the end now, we have a Helm demo, which is easily deployed complex application, in this case WordPress, to a Kubernetes using a Helm chart. So we're going to do it from beginning to an end here. I am over time. Okay, then we might skip the demo for now. Thanks for letting me know that. No worries. So the recommendations for next steps is networking, security, cost optimization, CI and CD, and service mesh. You should always look into these next. And then wrapping up with EKS versus ECS versus Fargate. We went through that. We went through EKS overview, how to create cluster on EKS, and a few best practices there, as well as we went through a bit of Helm. No time for the Helm demo, but no worries. You can find a lot of great resources on how to get you started with Helm there. And if you want to learn more, you can also use these resources here. And if you want, you can always go to my GitHub. I will be uploading these slides there. So that is a thank you from my side. I hope the timing wasn't too over time. You could always reach out to me on Twitter if you want to find out more. So happy to help you there as well. Thank you everyone for visiting the session, and I hope you have a great conference.
Hey folks, welcome to the PowerShell DevOps Cloud Conference. I'm Arsh and I have with me my very good friend Madhav. We both work at VMware and this session is going to be about how you can make your controllers more resilient using the WorkQ package. So let's get started. Can someone please confirm if the slides are visible?
Is my screen shared? Okay, yeah. So let's get started. Hi.
Yep. So before we talk about resiliency and all the Kubernetes related stuff, like let us go back to the basics and recall what a queue data structure is. A queue is a linear structure which follows the first in, first out order. What this means is that whatever enters the queue first will leave the queue first. So if A is added and then B will get added behind it, and A will be leaving the queue first and then B would be leaving. Adding into the queue is also called enqueuing, and removing from the queue is called dequeuing. So now that we have seen what a queue is, let us start returning back to Kubernetes and distributed systems and all the fun stuff and see what kind of faults can even occur in a distributed system. Madhav will take over from here.
So if you have just a single node in your cluster and you're running applications on just a single node, things are pretty simple and you are in general happy with the way things are working. In terms of you don't have a lot of complexity to deal with. But typically, this is not the case in most scenarios. Typically, things often look like this. You have multiple nodes, you have a cluster of nodes rather, and these nodes often communicate with each other over a network. And since communications over a network can get unreliable in some form, or the node itself can be faulty, or your application code might have bugs that cause it to malfunction, for example, then things might not work as you might expect. And since we are in a distributed setting and things can often break, uh, in distributed systems, failure is the norm rather than the exception. And due to this, we have to design for failure when we are working with distributed systems. Now, talking of failure, let's first try and understand what a failure actually is and how do we get there in the first place. So, what is the cause of these failures? So, if you were to look at a lineage of how these failures were to actually occur, it would look something like this. You first have a fault, which is basically something that goes wrong in your system. A result of this fault is an error, which is an unexpected behavior that your system um, displays. And then, as a result of that error, you have a failure from a user's perspective, or your system itself fails. So, to try and mitigate failures, we need to try and understand what faults are here and what different types of faults exist. So, let's try and understand that first. So, faults, there are three types of faults that can be thought of broadly in distributed systems. The first kind is called a transient fault, meaning that it occurs once and then things are fixed and back up and running again. Then you have something known as intermittent faults, which happen once, go away, come back. There's no fixed pattern to it, basically. And these typically are the most difficult to deal with because there is no fixed pattern to their occurrence. And then finally, you have permanent faults, which once they occur, they will persist unless until they are fixed. So the interesting one from these, at least for me, is transient faults, because transient faults are something that you can overcome or work around by simply retrying the operation that failed. So transient faults is typically along the lines of maybe if I try again, it'll work fine. The concept of retrying is extremely useful in distributed systems, but then again, as most cases, it's very important to think it through the way you retry something. That is, if you retry something which is not thought out correctly, it can even bring down your entire system as a whole. So, one of the worst case scenarios of not well thought out retries is something known as retry storms. Retry storms, for example, retry storms are cases where you have a request being sent, let's say it fails, and you know for a fact that this might be a transient fault. So what you want to do is you want to try and retry that. What you might want to do is, for every failure that occurs, you would want to send out 3 retries to be extra sure that your operation succeeds. But if you send these retries out right, like as soon as a failure occurs, what might happen then is that you might have an exponential increase in the number of requests that are being sent. So, for example, if you have one failure occurring, and for every failure you send out 3 requests, and if those 3 requests fail, you have 3 for each of them, and so on. So you have an exponential sort of tree exploding over there. This is where this is what is known as a retry storm, and the way to sort of mitigate this and avoid this is to pace your retries, meaning that what you could do is you could have exponential backoffs for your retries. So your first retry, you retry it immediately as soon as you have a failure. If a second failure occurs, you retry it after, let's say, 2 seconds. A third failure occurs, you retry it after 4 seconds, 8 seconds, and so on. So you exponentially increase your retry periods. This sort of ensures that the entity that is failing has sufficient time to recover and not be overloaded by an explosion of requests, which would ultimately just lead to your entire system failing. So you can pace your retries. Another way to mitigate this is to add something known as jittering in your retries. So jittering is adding a random amount of delay to each of your retries. So this can be in conjunction with your exponential backoff, for example. So the reason I'm talking about all of this is because this is first of all, it's really interesting to think about, and secondly, this is something that Kubernetes and the client Go package provide as part of its work queue package. Just so that we have an end-to-end picture and context of everything that is going on, uh, it's important to know about these problems and how you can mitigate them. So I'll let Arsh take over from here for a few fun demos and examples.
Sure, let me share my screen. The slides up. I do not see them. Yep, there we go. Nice. So ClientGo is a library used to communicate with a Kubernetes cluster. And if you're working on a project which needs to talk to a Kubernetes cluster and you are using Go, you're very likely to come across it since it is the official Go client for Kubernetes. It is built and maintained by the Kubernetes Special Interest Group API machinery. And so before we like get into the work queue, which is a package present as part of the client Go, let us make things a bit exciting and have a super quick demo on client Go to keep this talk a bit more beginner friendly. I will share my code editor now. Okay, yep. So we begin the same way we would begin writing a normal Go program. And the first thing we want to do is set up a Kubernetes client using our kubeconfig environment variable. So we can get this using our os.get env package. And here we'll set this variable later explicitly so that it is easier. And once we like have the user's kube config, from here we can pull out the config object which we want to work with and check for an error. So we would just grab the config object and an error while grabbing the so we are grabbing this like from the flags, so which is like why we use this method. And now that we have the config, from here we actually grab our Kubernetes client, or client set as it is called. But before that, we should also check for errors like we always do. And then from here, like, we can grab our actual client, which is more of almost always called client set. Then again, we can check for errors. You could have also used new config or die, and if you use that, you wouldn't have to check for errors. But anyways, now that all the setup stuff is done, we can do the fun parts, which is like actually getting stuff from this API. So let us, for this example, print a list of nodes which are present. And for that, we can say client set. And so I know this is in core v1. And so this is where you'll need to look up the docs to know the different groups and versions and kind in Kubernetes, so you know where to get stuff from. So here from v1, we grab the nodes, and then we also want to list them, and list would take a context and list options which we can specify as empty here, so that should not be a bother. Once we have the list of nodes, again we'll check for our error, and to keep it very simple, we can just iterate through our nodes and print out the names for the sake of this example. Looks good. And so I'll show you what the output is when I use kubectl, so that we can confirm that ClientGo is not messing with us. And when we run this program, it should not work because we did not specify the kube config. So let's export our kube config. And now it should work. So here you see we are like, I'm currently using kinds and we are on a single node cluster. So it printed out the name for that thing. Let us go back to the slides. And so this was like a bit about client Go, and you saw that how easy, intuitive it is. And the fun part is that while it's like very simple, it is, you can also do a lot of powerful things with it. So now that you know like what client Go is, one thing you would come across when writing your controllers using client Go is shared informers. So we can stay informed about when events like pod creation, node joining are triggered by using a primitive export by the Kubernetes and the client Go called shared informer, and this is present inside the cache package. So previously, each controller had its own informer cache that it would use, and this led to resource consumption issues in terms of memory at the node level at which the controller is running, and it also led to additional number of connections that the API server would need to maintain. So it was due to all of these problems that a shared informer was introduced, which is a shared cache among different controllers that might be operating on related or similar resources. With that, let us go back to our previous code and see how a shared informer can be used. Now, there's been a lot of back and forth. Yep. So if we return to our example and leave stuff as it is, we see that like first we have to initialize an informer factory, which we can do using informers.new shared informer factory. And to this we pass our client set, and we also, the second argument this needs is how often the informer should perform a resync. But here for simplicity, just let's just like set it to 0 to disable resync. You should like not be doing that when you're writing actual production code. unless you want to. But okay, so now that we have our factory, let us initialize an informer that is geared for pods in the core V1 group. So this is related to what I was saying earlier, that you would need to look where your resource is in order to know where you can get it from. And pods we know are in core V1. We can initialize an informer for that. Then we also create a simple channel which we'll use later for stopping our informer. And now that we have these, let us defer the closing of this stopper channel we just created. And this channel is like basically used to stop the informer's run loop, that is like watching and listening, listing the pod resource. And but now the important part where shared informers where you need to pay attention is when we add like, let me show you first. We'll add event handlers which will help us to write our functions which would be invoked when different kinds of events occur. And this is now you could essentially print, but I want this to work for like regardless of what resource it is passed. So even if it's passed pods or nodes or anything, that is why I'm doing this conversion here. And this conversion basically helps me to do this new pod. So if you see that we can invoke mObject dot get name. Yeah. So this is like, you can skip this part, but this was like so that regardless of it's if it's a any kind of resource, we can just do a get name here or get namespace. But the essential gist is that we are adding handler functions, just the one add function for now. And this function is called every time an object is added to our informer's underlying store. The single parameter in our case will always be a pod, but we needed to convert it, and I used the v1 package for this because it provides an object interface that makes retrieving metadata on any Kubernetes object easy. So methods like get name and get namespace will work for everything this function receives now. But once we are done with this, lastly all we need to do is tell our informer to run and pass it the channel we have created. And we have deferred the stopping of this channel, so it should like continue running. But when we run this code now, you'll see that it did all of this stuff. But if I try to create a new pod now, and let's say the pod is called hello world, you'll see that it looked for it and it printed out that it found hello world. And if I create another pod by the name hello world 2, you'll see that it is working. And we didn't close it, so we'll have to like manually interrupt it. But so what I want you to take from here is this adding of handler functions which were present like in the shared informer and actually were responsible for doing this stuff. Now returning back to our slides and connecting everything, connecting the demo you saw right now with the rest of the talk, which is about queues and the worker queue package, we'll return to our slides. Just give me a second, it's loading. All right, so we are back on our slides. And so let's see like where queues fit into this entire big picture. So if you look closely in this at this diagram, you'll see that we have a reflector which is also a package inside cache, and it watches the Kubernetes API for the specified resource type kind. Just again, like, should I increase this? Maybe is that better? Yeah. Sorry. So Yeah. As I was saying, if you look closely, we have Reflector, which is a package inside Cache and watches for the Kubernetes and watches the Kubernetes API for our resources. The function in which this is done is the list and watch function. So what will happen is that when the Reflector receives a notification about the existence of a new resource instance through the watch API, it gets the newly created object using the corresponding listing API and puts it in a Delta FIFO queue. FIFO is just first in, first out, which we talked about in the second slide. And then an informer pops objects from this Delta FIFO queue, and there is also an indexer present. And to be honest, it's not much related to this talk, but to give a brief about it, it's like responsible for providing indexing functionality over objects. And if you look at the diagram, you can like also skip the bit about the REST event handlers reference and the informer reference bits, just so that you don't get confused and overwhelmed by the amount of information. But because like these two things have to do with the working of custom resource objects, but basically the part you need to focus on is that from the informer we reach the resource event handlers, which are the callback functions which will be called by the informer when it wants to deliver an object to our controller. This was the function where we were like in the demo we were simply printing out that a new pod was created. But instead of printing in these callback functions, when you're writing your controller, the typical pattern while writing these functions is to obtain the dispatched object's key and enqueue that key in a work queue for further processing. So this is where queues start to come into the picture. If you look at this code here, you'll see that for the add func on line 178, we get the key for our object and then add it to the queue on line 181. Now this queue is provided by the work queue package as you see on line 171. And this package is what Madhav will be covering next. So finally, so the gist is that due to shared informer being a shared cache, the producer consumer pattern starts becoming very evident. What is the producer consumer pattern? The consumers here are the controllers, which view the shared cache as a producer. So this producer, that is the shared cache, doesn't really know what the state of the consumers is or what they are working on. So to simplify this coordination between consumers and producers and to facilitate retries, the producer, that is the shared cache, just puts events into a queue like you saw in the previous diagram. And this queue is what Madhav will be covering in the next slides. Madhav, you can take it from here.
Thanks. First of all, just sorry for all of the switching back and forth. I know it's been a little weird, but that was the last switch. Sorry about that. So now that we have sufficient context in terms of what client code does under the hood, although it's a lot of information to take in, let's finally talk about where the work queue package comes in and how you can possibly use this to facilitate retry mechanisms or speed up your processing in terms of having multiple workers and so on. And what does it mean to have multiple workers in the first place? So the work queue package, on a broad level, provides the following four functionalities. So the first functionality it provides is that it's fair, meaning that all items will be processed in the order in which they are put into the queue. It is stingy, meaning that if one key is added to the queue and the same key is again added to the queue, that key will be processed just once. The work queue package ensures that the processing of that key happens only once, and subsequently, since you can also have multiple entities that work on this one key, it's possible that you can have that one key being processed multiple times due to concurrent execution. The work queue package ensures that that does not happen. Then next, you can have multiple producers and consumers, meaning that you can have multiple entities piping keys into the queue at the same time and multiple entities popping these keys and processing them at the same time. And as a miscellaneous functionality, it also provides something known as shutdown notifications as well. So to try and understand this functionality provided, we'll first look at the following two things. The first thing is, how does the queue itself work and how is it structured? And subsequently, what are the different extensions to this queue that are provided, and how can we use them, and what does it mean to use some of this tooling that is already provided. So to try and understand level entity called type, I'm using the same terminology that is already present in the source code, so that should you go and refer to the source code, these slides make sense. So you have a top level entity called type, as part of which you have a queue, as we would expect. But additionally, you also have two sets called dirty and processing. Now, the purpose of these sets is as follows. The dirty set holds items that are in need of processing but aren't yet being processed. The processing set holds items that are currently being processed. And we will see why we need these two different sets, and why not just have one queue and things would work fine. We'll see why the need for these two sets. So how does enqueuing work with these two sets? So just like a basic operation, we want to put an object into the queue. How does that work? So let's say we want to add an item. So you call add of that on that item. So the first thing you would check is, does the dirty set have this item? Meaning that, is this item already marked as needing to be processed? If it is already present in the dirty set, then you don't do anything basically, because it's already marked that it needs processing and you don't really need to add it once again. So you exit over there. But if it's not present in the dirty set, then you go ahead and add it to the dirty set, hence marking the item as it needs to be processed now. Now, after inserting it into the dirty set, you then check if the processing set has that item, meaning that you check whether this item is already being processed by some worker that is using this queue. And if it is already in the processing set, you exit. If it is not in the set, you finally go ahead and add that item to the queue. So the important takeaway from this flow diagram is that an item will be added to the queue if and only if it is present in the dirty set, but not in the processing set. And this is important to try and avoid duplicate processing of items, as we will soon see. Now, due to this queue pattern, you can have a few interesting points that we can note. So the first of which being multiple producers producing items to be processed, and multiple consumers can pop these items and process them. This essentially means that you can parallelize work that needs to be done, meaning that you can have multiple such workers that you can have. So if you are writing code specifically in Go, you can have multiple Go routines just like popping things out from the queue and processing them. Now, the next interesting question that comes up is that what happens when an item is done processing? Meaning that, let's say, one of the workers is finished processing that item. How does the queue react to this finished processing? This is the question. So when an item is done processing, you call the done function on that item. So let's say you call done. When you call done, the first thing it will do is it will delete this item from the processing set. This just goes to show that you are marking that item as no longer being processed, which is intuitive in nature because you are done processing the item. Subsequently, you also check that whether the dirty set has this item already again or not. If it does, then you go ahead and requeue that item. But if it does not, then you exit. Now, the reason that we are checking whether this item is present in the dirty set or not is because it's sometimes very much possible that when an item is being processed, the same item can also be pushed in by a producer into the queue. So as we saw earlier, if an item is pushed into the queue, it will first be put into the dirty set. So here, as we can see, if an item is put into the dirty set, if an item is removed from the processing set but is present in the dirty set, you go ahead and requeue that item back again. This helps with things like if you want to retry while something is already being processed, how do you do that? And for subsequently, should that item even be processed, which we will soon see. So how do we ensure that this item is processed just once? And in the concurrent setting, how do we ensure that, how do we again ensure that the same item isn't being processed multiple times? Now, ensuring this is important because if we duplicate process an item, the best case scenario that you can have there is that you end up doing additional work to rectify the mistake. And the worst case scenario that you have is that you have a thrashing effect of sorts of processing the item. The reason for this is mainly because your processing of an item can be something in terms of maybe creating a resource. So let's say you are reacting to some event that you pulled out from the queue. That is along the lines of maybe you needing to create a pod, for example. So if you are if you are processing that item more than once, you will end up creating additional resources in the Kubernetes API, which subsequently will lead to your desired state not matching your current state, and then you would react to that, and then the same mistake might occur again, and so on and so forth. So you have like a thrashing effect of sort that occurs. So to fully prevent that, how does the work queue package ensure that it's not done multiple times? So let's look at an example for that. So let's say we have items being added to the queue. So 1, 2, and 3, they come in that order. So since they are added to the queue, first things first, they will be put into the dirty set. But since none of them are there in the processing set, they will also be added to the queue itself. So as you can see, you have 1, 2, 3 being added to the queue. Now we do a get operation. Get operation meaning that is basically a pop operation. So you want to get an item for processing. So when you do a get operation, it will put the item at the head of the queue, which is 1 in this case. It will mark that as being processed. Subsequently, it will delete it from the dirty set, meaning that this is marked as no need for being processed because it's already being processed. So it will remove it from the dirty set. And finally, it will return it to the user or the worker or whoever is consuming from this queue. Now, let's say while this 1 is being processed, another item 1 gets added. So you have an add of 1 again. So as usual, you first put it in the dirty set. Now, since this is already present in the processing set, you do not add it back to the queue just yet. And remember from our flow diagram that an item will be added to the queue if and only if it is present in the dirty set and not in the processing set. So now if we call done on the item 1, what's going to happen is it will remove it from the processing set because it's done processing it. But we also have an item 1 in the dirty set, meaning that it will re-enqueue that item and remove it from the dirty set. It will not remove it from the dirty set. Sorry about that. It will requeue the item 1. So a few things to note here. We've been mentioning keys being pushed into the queue and keys being processed. These keys follow a specific format, meaning that the format that these keys follow is of the form resource namespace / resource name. So let's say you're working with pods. So the key in that case, let's say your pod is running in a namespace called my namespace. So the key in that case would be my namespace / your pod name. But if the resources does not belong to a namespace, that is, it, for example, is cluster scoped, then your key name is just going to be resource name. So finally, coming to how do you make it resilient, right? So what type of queues does the work queue package have? There are two main entities that the work queue package defines for you. The first being something known as the delaying queue. So this just extends our main or core queue functionality that we just saw by adding functionality to add an element after a specified duration. So you can specify that I want to add this element, but I want to do it only after, let's say, 2 seconds or 3 seconds. So the delaying queue does this for you. Then uh, the delaying queue isn't directly used as much. Um, it is used in something known as the rate limiting queue, which is then very often used by all Kubernetes controllers that ship out of the box, or custom controllers that one might write for their custom resources. So then you have rate limiting queue. This just extends the delaying queue uh, to rate limit items that are being added. So when I say rate limit items that are being added, what I'm trying to keep in mind is the context of trying to prevent retry storms and items in a thoughtful manner, or by being mindful of um, transient errors, basically. So the rate limiting queue, if you look at uh, how it, if you look at the rate limiting queue, it provides APIs such as num requeues for an item. So num requeues basically just returns how many requeues were done for this particular item, and the default rate limiter that exists is the normal rate limiter that one might know of. So let's say that an item is requeued 3 times, then it will wait. If another requeue is attempted, it will wait for 2 power 3 into some base delay. So 8 into some base delay units of time before actually putting it back to the queue. And this is just the default rate limiter. You can provide your own custom rate limiters as well by just implementing the rate limiter interface that the work queue package provides. And by using rate limiting queues, what you can then ensure is that if processing of an item fails, you can rate limit retries in a way that uh, in a way that is resilient enough for you to uh, not not orchestrate another retry storm, let's say on the API server. So that's why rate limiting queues are helpful, and this is also the reason that it's used across all controllers that ship out of the box in Kubernetes. So if you look at deployment controller, replica set controller, endpoints controller, all of those controllers will use a rate limiting queue as its queuing medium. So that being said, so this article provides a really good overview of just controllers and writing controllers in general. And it provided a great flow diagram of how you can use a rate limited queue in your controller. So as you can see, you first add a key to your queue, you then get the key, and then you process the key. But if there is an error, then you would want to retry. So you would also want a cap on the number of retries that you have, because if you don't have a cap, then the number of retries can just not have an upper bound. So if your number of retries is in a reasonable bound, you rate limit addition of that key, and then you retry subsequently. So a few practices that one would like to keep in mind while using this is that always handle errors outside of your business logic. So what I mean by this is that if your business logic is to perhaps uh, react to some event that occurred, so let's say that a pod creation event that occurred, so your add func, that is the resource event handler that Arsh talked about, is executed. Um, the logic as part of that occurs. Let's say you want to print some message onto your terminal, or you want to create something externally to your cluster. Whatever your business logic is, any error that occurs in this business logic, handle it outside of that business logic function. And handling this error typically consists of requeuing it. So what you want to do is you want to decouple uh, your whole business logic from where the actual requeuing is done. And subsequently, another really interesting point to understand and keep in mind is that what you want to do is, when you want workers to start popping items from this queue and start executing them, um, you only want to start these workers once your caches have synchronized. And what I mean by this is that what Arsh spoke about in the shared informers part, the intent of the cache is basically to reflect the state of the world that exists in etcd, which it gets through the API server. So the whole point of the cache is to try and bring that state, but keep it locally so that reads happen against the cache, and it's more optimal from a performance standpoint. So once your cache is finally synchronized, so the client Go package also provides ways for you to know if your cache is synchronized. So once your cache is synchronized, only then start workers. This is important because if you start your workers before your cache is synchronized, you might get events that you don't have full information about, or you might have rapid production of the same sort of event that you are working for. So, for example, if you create a pod, then you have an add event and 3 to 4 update events that happen. Those update events are typically because of pod lifecycle changes that occur. If you start your worker at this point, then it might not behave the same way. And if you start it after the cache is synchronized, it will behave the way you want it to, mainly because all of these multiple rapid events that occur, they will be collapsed into a single effective event in the work queue package. Like, not literally collapsed into one event, but you will be processing just the latest event from your work queue package. So these are a few practices that you could keep in mind, and it's really interesting to think about as well. Now, additionally, the work queue package exposes certain metrics that are available in the /metrics endpoint of the API server, meaning that these metrics can be scraped by Prometheus, for example. So the work queue package exposes metrics such as how many retries are done by a certain controller, or how much time is spent in the processing set, or how much time is spent in the done set, and so on. So an example of what these metrics look like. So you have a bunch of these metrics, such as how many additions are done, what duration in total was spent in the processing package, and so on. This might be helpful to you if, for example, if it spends too much time in the processing package, meaning that either it's taking too much time to actually process the item, or if the item has already been processed, it's taking way too much time to call the done function on that item. This could be maybe because of the fact that in the code path where the done function exists, you have a few blocking system calls that aren't as performant as you might want it to be. So these are a few useful metrics that you can use to try and debug performance if needed from the work queue package. So a few useful resources and references that we found while preparing for this talk were some of this. I would particularly recommend looking at the sample controller and the client Go work queue example. These are pretty simple examples of how to write a controller and using the work queue, but they're really effective in trying to understand the nitty-gritties of how to use some of these packages. So that being said, thank you so much for attending our talk. And thank you, PDC, for having us. And if you have any feedback or questions, please feel free to reach out to us either on Twitter or the Kubernetes Slack. These are our handles there. And yeah, thanks for joining. Okay, so there is a
Techaholic was conceptualized in mid-2018 as an open community platform. Techaholic connects industry professionals, vertical experts, and learners together, bringing real-world relevance and career exposure for enhanced learning. Our vision is to enable professionals and organizations to achieve more through the community collaboration. Our mission is to nurture industry-ready professionals who can enhance nosiness outcomes with skills on upcoming technology landscape. And our values are to make everyone shine by sharing our knowledge, bringing honor to individuals, encouraging innovation by using the latest technology, networking to enhance collaboration, and encouraging excellence in technology-enabled solutions. We are creating communities with the motto of Go Far, Go Together. We empower individuals to achieve more through their skills without worrying about anything else. We help our community members to become industry-renowned, self-dependent professionals. To achieve industry recognitions, you can join our community to work with our existing industry-renowned community leaders. Our community leaders could mentor you and provide the stage to work with local and global communities. Mentors can lead you to the next level of growth. Techaholic empowers individuals to achieve their career aspirations by connecting them with the right mentors who are proven industry veterans and subject matter experts. Internships help you with real-world experience. Today's students are tomorrow's leaders, so we will not leave you alone. We have open internship programs to onboard technology enthusiastic students through formal process. Lead your digital transformation assisted by our industry veterans and technology community experts. Our designs are centered around business and technical requirements. We optimize your cloud designs to enhance administration and user experience. We secure your cloud with defense in depth. We provide guidance on cloud governance and compliance. Techaholic can also help you solve problems like lack of flexibility in capacity and cost optimizations, time to execute, efficient remote working, and infrastructure monitoring. Techaholic is making it easier for both freelancers and organizations by inventing a new way of working with freelancers globally. As a freelancer, you can choose your assignments either through your own network or through our network. We take care of all the onboarding tasks so that you only focus on your assignment. We are continuously growing our community to help individuals and organizations in capability building with skill-based learning. In the ever-changing job roles, we are extending the learning outreach by nurturing the future-ready and most desired professionals in the industry. We bring together a large array of technology professionals with varied industrial accreditations, eager to help build enterprise solutions and enable the learners. Now let's look at some of the popular industry certification courses offered by Techaholic.
Hello and welcome. Hi, my name is Thomas Maurer. I'm a cloud advocate at Microsoft, and I'm happy to speak to you today at PDC Conf 2021, which makes me super happy again to be here. Great conference, great people as always. And in my session, we're going to talk about hybrid management, or I should extend this, not just hybrid cloud management, but also multi-cloud management. So we're going to talk about how you can deal with managing environments which are not just in Azure and as a cloud provider, which actually span across your on-premises, edge locations, or other cloud providers as well. How you can use DevOps techniques to manage your applications and deploy your applications in these environments, how you can make sure that everything is configured securely, and how you can actually take advantage of Azure services running outside of Azure. So you could run, for example, things like Azure SQL wherever you need it. So this is what we're going to talk about. And again, I promise you, I have prepared a lot of demos. So the big part of the session will be demos. I have a couple of slides, so at the beginning especially, so stay with me there. I just want to outline a little bit why we are doing this and what's the plan. But after that, we're diving directly into demos, and I can show you absolutely a couple of awesome things. Also, make sure you tweet out about the session. Tell me what you like, what you don't like, and all the stuff we're going to have a look at. So with that, let me go on and actually start with the why we're actually doing this. So one thing we realized when we were looking at customer environments, we saw that they're getting more and more complex, right? They're evolving, and there are certain challenges now coming to customers. By getting the advantages of all these awesome technologies, especially in the cloud, you still have to scenarios where again, you get some additional complexity. And so we actually look at why is that, right? And we're looking for reasons why this complexity is actually created. So what we're seeing is that most customers are managing tens, hundreds, if not thousands of different applications, right? Some of them can be very modern application written in very modern languages, for example, like .NET Core. They're running on PaaS services or containerized or even serverless in many cases. However, there's also a big amount of traditional applications out there which runs inside virtual machines or even on physical machines as well. And IT admins at the end and developers end up in taking advantage or managing all of these different applications. The other thing we saw is that our customers have a very diverse infrastructure, right? They're not just usually just one thing to manage. They're not, in many cases, not just cloud-only companies. They're running their own data centers. They probably use service providers. They have edge locations, as we call it, which can be branch offices, factories, retail stores, and many other places where they also need to run different kinds of applications and services. And then they're managing different hardware and different devices out there again. And that also obviously adds to the complexity. Now, last but not least, another big part where we see adding complexity to the table is when it comes to multi-cloud, right? There's some customers doing multi-cloud because it's a strategy for them to actually do this. So they will go out and then say, hey, we want to not just depend on one cloud provider. But then also there are customers which are basically just end up in a multi-cloud situation where, for example, department started with a cloud vendor, and then the company decided to go with, for example, with Azure as the main cloud vendor, which is actually, by the way, a good thing to do. And then they will not just migrate everything over, right? No one has time to just migrate everything over. So they end up in this multi-cloud approach. And as you can imagine, dealing with one cloud provider can be complex, right? But in adding multiple cloud providers to the mix, you add drastically more complexity to this environment. And we need to have tool sets and features available to span across these different environments, span across on-premises, span across edge locations, span across different cloud providers to make sure that we can manage these things, but also can build applications in these different types of environments without building a different application, which is the same thing, but depending on the environment. So That is what we're going to look at. And Microsoft, in Microsoft, we really try to address this in terms of what our hybrid solutions are, right? And this is where I just want to quickly take out this marketing slide, because it's a very high level slide on what we are offering. And I want to make a couple of points to this. We don't just have one solution, which is hybrid, right? We have actually a large set of services and products which actually help you doing hybrid, right? So for example, if you do need to do IoT, we have a large set of IoT offerings which help us with that, which is a whole lot of, like a whole story for itself. And then we also have, for example, our Azure Stack family. So it's a portfolio of products. For example, it's not just one product anymore, which provides you with cloud-inspired hardware. So you get, for example, like Azure Stack Hub as a great solution if you're running, for example, in a disconnected environment and you need to have your own portal, your own Azure Resource Manager. We offer Azure Stack Edge for your machine learning and AI workloads at the edge. And then we also have Azure Stack HCI, which is a super interesting offer, and I will talk a little bit more about at the end, which offers you for hyper-converged capabilities to really open and depending on your scenario, what you need, right? From very small clusters to node systems for branch offices, for example, but then to very high efficient clusters in data centers. You can really build there on that. And then we can enable a couple of really cool scenario again. So bear with me. I will talk a little bit more about at the end. And then we come into the Azure Arc part, and that is something where it really becomes interesting in terms of, okay, bringing Azure services to any infrastructure. So what does that mean? So that is one of the features of Azure Arc, actually, is like, or one of the things we want to address, right? Our customers are telling us, look, we love, for example, Azure SQL, right? We love the Azure SQL service, but for one of our scenarios, we can't really take advantage of your Azure region. That place or that office or that data center where we want to use Azure SQL, it's too far away. Like the Azure region is too far away from it. Like there's too much latency in between, or our internet connectivity is just not great. We cannot rely on it, or we don't even have internet connectivity there. Or then there are data sovereignty challenges, right? So there are many reasons why you would potentially go hybrid and can't use an Azure service. So if you can't use an Azure service, what we will do is actually, let's bring the Azure service to you. And I'm going to show you how that looks like so that you can deploy an Azure service wherever you need it. That will also help developers and architects actually then build applications which always look the same. Doesn't matter where they're actually running, in which location they're running. So you can still take advantage of Azure PaaS services on other locations. And then let's talk about the line in the middle. I think that is what we're going to have a big chunk of time spent on, actually the single control plane with Azure and Azure Arc, right? So Azure really offers a great set of management technologies, and we will dive into this to actually manage Azure resources at scale, right? And our customers told us this is fantastic. I can really, this is really a big advantage when it comes to managing cloud resources. But then they told us, well, there are resources outside of Azure. There are resources running in my own data center. There are resources running at other cloud providers. And so that is where Azure Arc comes in. It allows our customers to actually connect these resources, like let's say servers or Kubernetes clusters, to the Azure control plane. And so that is what we're going to have a look at in just a bit. So what can Azure Arc do on a high level? If you need to say it in one sentence, it basically extends Azure management and Azure services to anywhere. So this allows us to get that single visibility, that single endpoint where we get central visibility, operations, compliance, where we actually can do all the management, but then also helps us building these cloud native apps and deploy them to anywhere, right? And use DevOps techniques to actually do so. And then last but not least, to actually then take advantage of Azure services in these locations. So there's some great stuff which Azure Arc offers. And before we actually dive, before we go further here, let's just have a look how that will look like. So let's dive into a little bit more technology here and say, hey, this is what we think. So again, you have Microsoft Azure, and we have that control plane to manage Azure services. But then to extend this to Azure services which are running outside of Azure, we have Azure Arc. And you can see here, this is like offering the extension to the control plane. And then we talk about two different things. One of them is Azure Arc enabled infrastructure. So that is where you can onboard existing resources such as Linux servers, Windows servers, Kubernetes clusters, and other things to your Azure environment. And then we have Azure Arc enabled services. This really allows you to basically go out and deploy Azure services wherever you need to. And instead of just talking about this, let's now switch to my demo environment to actually show you a little bit more about this. So here I am in the Azure portal, right? And you can see here I'm in the all resources page. So you can see here everything in Azure is basically a resource. So this starting from a virtual machine, but then also, like, for example, if you look at databases, disks, IP addresses, network security groups, network interfaces, everything in Azure is a object. It has a type. It usually is joined to a resource group. It's part of a location and part of an Azure description. And then I can also use, for example, tagging here to actually organize these resources. Now, again, this helps really if you're doing large-scale deployments, or even if you're in smaller environments. This is great to help actually get that overview and get that visibility. Now, again, as I told you, we understand that customers do not just have resources in Azure, right? They're also outside of Azure. So how can we manage these? So to show you this is I'm going to limit here the scope. So what I want to do here is I just want to see all the servers running in my environment, right? So what I'm going to do here is I'm going to search for Azure Arc and just limit that for Azure Arc. So this means I already onboarded a couple of servers which are outside of Azure. So they're actually running, some of them are running here underneath my desk in my own little data center, and some of them are actually running at other cloud providers. So that is that. And then I also want to see, obviously, my Azure VMs as well. So I put these in and apply that filter. And what you can now see here is now I have a list of all my servers I'm actually running. Servers I'm running in Azure, like my Azure virtual machines here. You can see that here. Or also my servers, like these machines here, which are in purple, which are actually Azure Arc enabled servers. So you can see here they're also showing up. I can see they're also part of a resource group. They're also part of a subscription, and I can also use tagging for them. So that means I can now get some simple features here. For example, I can go out and say, hey, I want to use, for example, tagging. So let's go for cost center here. So show me all the servers which are belong to these three cost centers. So if I apply this, you can see here, now I can sort my servers, for example, now for cost centers, but again, there's absolutely open how you want to do that, like you do with other Azure resources, right? So you get that extended visibility. Now, this is not just, when I talk about the portal, this is obviously not just part of the portal. This is now part of the Azure Resource Manager. So these things are actually representations within Azure. Even though the servers and the data is outside of Azure, they become basically a native Azure resource. So that allows me to use things like, for example, the Azure Resource Graph Explorer. So I can use Azure Resource Graph. So if, for example, I cannot just list servers here, but I can also do that, for example, here with a resource graph query. So if I run that query, you can see here, I get, again, basically the same list of what I just showed you with all my servers here. And I can see here, when you look at the type, I can see here that I have Microsoft.compute virtual machines. Those are actually my Azure VMs. But then if I scroll down, I can also see here my hybrid compute machines, which are basically my servers running outside of Azure. So I can do all these queries and get all that benefit because they're not part of the Azure Resource Graph. I can also then see, for example, like if we have some managers or you need to show something to your managers, you can easily do also a nice chart here for these queries if you want to. Oh, sorry, I need to group this and take that one, run this query, and I can do a nice donut chart here It's early morning, so I would love a donut right now. No, but you can see here my point. You can actually take advantage of all these capabilities we have. Now, you probably say, okay, Thomas, this is great. And now we get some visibility into everything. But I actually need to do something as well, right? I need to have some more advantage. I mean, I don't just want to know what servers are out there. I want to know a little bit more. And with that, I want to show you policy. Now, if you're not familiar with Azure Policy really allows you to configure your Azure environment in a certain way. So you could go out and, for example, configure your Azure environment, say, hey, developers and IT pros, you can only deploy your applications to certain Azure regions. You can only use a certain size of Azure virtual machines. Now, what you can do here as well is you can actually then see different assignments. Now, what I didn't tell you is that, or what a lot of people don't know, is that there is also Azure Policy guest configuration. Now, this allows me not just to configure the Azure environment, but also the operating systems of VMs running in Azure, right? And with Azure Arc, VMs which are actually running outside of Azure. So I'm going to show you this here. For example, if I do a new initiative here, which is just a group of policy settings, I can go out and I get some custom rules. So I can build my own policy definitions, but I also get some built-in ones. And some of them here you can see are technical ones saying, okay, hey, enable Azure monitoring for VMs. But then if you scroll down here, you can see we also have some for specific industry-specific certifications, right? So FedRAMP, for example, we have federal, Canadian federal, we have IRS, we have ISO, UK official, NHS, we have, and a ton of more, right? So we have a couple of them here, which you could actually take advantage of. And this will help you to actually find out if your environment and your servers are configured correctly. Now, in my case, I want to take advantage of a very simple one. So what I want to do is I want to audit my machines for insecure password settings. So I'm going to select that. And then I'm going to do next. And then I have some parameters here, which I want to work with. And so what I can do here now by default, it will just go out and do my Azure servers. But now with this setting, if I set this to true, I can also apply Azure policies to my servers running outside of Azure. So again, I would then go through that process and at the end actually go deploy that. And this will then start the auditing process. And that will take some time, right? So like in a good cooking show, I already prepared something to do that. So what I can do here now is I can look at compliance, and you will see a couple of different things here. First of all, you see that I do a horrible job when it comes to compliance, right? There's a lot of red non-compliant resources, so I need to fix that. But then you can also see that here is, for example, the initiative I just deployed, which actually audits insecure password setting. And you can see that my environment is not compliant with this. So you can see that, like, what are actually the rules here? These are like password length, minimum age, and stuff like that, which need to be set. That's one thing. But more interestingly, I can see what resources are not compliant. And so by default, I would just see all my Azure VMs, as I see here, for example. But then if you scroll over, you can see here that I can also see my hybrid compute VMs, which are the Azure, or my hybrid compute servers, I should say. These can also be physical servers running outside of Azure, right? So I can assign now these policies to servers wherever they are. And I can actually go out and audit my machines in that way. Now, so what did I just show you? And again, I have lots more to show you how you, for example, onboard a machine and how you can actually take advantage of that. So let me quickly jump back to the slides and show you a little bit of an illustration of what I just showed you. So if I'm an Azure customer on the left side, right, we as Azure customers, we basically use tools and experience like the Azure portal, PowerShell, CLI, APIs, you name it. And when we are interacting with Azure, we do that with the Azure Resource Manager. That is the magic behind the Azure deployments, role-based access controls, description management, tagging, search, grouping, all that cool stuff, and a lot more we have. And on top of that, we also offer a couple of management services, such as monitoring, update management, backup, security center, and many, many more. And before Azure Arc, we actually offered that just to like Azure resources, right? So you use the Azure Resource Manager, like the name says, to manage Azure resources. But then, as you can see on the bottom, customers are also having different environments outside of Azure. So they have all the cloud providers, they have their on-premise location. And what actually happens is usually they have existing tools they use to manage these environments. So for example, for server management, for Kubernetes management, and so on. Now, this is great, but now you end up having all these awesome tools in Azure, and then you have other tools running on-premises or at other cloud providers. So what Azure Arc can do for you, it can really bridge these resources into Azure, and then actually make them show up there, right? So then you can start using Azure Resource Manager and management services to do that. You can still use, by the way, your existing tools here as well. So it's not just that we create a dependency and to Azure. You can still keep on using your existing tools as well. So what can we actually manage? When we talk about Azure Arc-enabled infrastructure, then I showed you like how you can. I showed you like a lot about how you can do that for servers, but it's not just about servers, right? We can also manage Kubernetes clusters, and can also manage existing SQL servers like Microsoft SQL servers as well. And I'm going to show you a little bit more what you can actually do with these servers right now. So let me jump back to the Azure portal here. So here I'm back in the Azure portal. And if I want to do like something with Azure Arc, I just go basically to the Azure Arc page. And this is what we call the Azure Arc Center. This is where you're one place to go if you want to manage your Azure Arc resources or add new Azure Arc resources to it. So you can see here already, like we help you obviously to onboard some infrastructure. Some of the infrastructure you can some of the capabilities you can use for free. Some of them are cost money. So you will see here on the pricing on the bottom here, you can find more information about what is actually the cost involved in running these. And then if you scroll through the left side, the first thing I want to show you is actually the infrastructure part, right? So this is like what I mentioned, where you can onboard existing resources. So we have servers here. So if I have a list of my servers, you can see here that some of them are connected, some of them are currently offline. If I want to onboard a server, it's actually pretty simple. I will click the add button, but what happens in the background is very simple. So what we're going to do is we're going to deploy an agent. So we're going to download the agent, install the agent, and then register that specific server to Azure. Now, we can now have a little bit of onboarding experience. So we help you generate the script of doing all of that. So we have one for single server. This will actually then prompt for your Azure login. But you can imagine if you do that for hundreds, if not thousands of servers, you probably don't want to use that and build some automation around it. So you can also use and create a service principal, which only has rights to actually onboard these servers, and you can create a script for that as well. And then if you're already using, for example, Azure Update Management, existing deployments, you can also now add these servers to Azure Arc as well. But so let me quickly go through this thing, add a single server one, just to explain a little bit, to get some insights how this works. So what we need is, we have some prerequisites here. So obviously your servers need to be able to connect to the Azure API on port 443. So it's going to be outbound connectivity to these, to a couple of Azure APIs. Now, I will show you that this is not just a public internet. So if you're behind public internet, you can also use the Azure private link. So if you have a VPN connection or express route, you can also go through that as well. But that is essentially what you need. Like if your server runs anywhere, you can just use this, and it's going to be encrypted through that. You need to have local administrative permissions, which basically is only needed one time to install the agent. And then you need to have an existing resource group where you can add your servers. So then we go through and we say, okay, to which subscription I want to deploy that. Where do I want to which resource group I want to add my servers. And then I can choose the closest region where I want to deploy my server, for example. And then I can say, okay, which operating system it is, the connectivity mode. And again, I want to highlight this very much. So we have public endpoints, which would mean you go basically encrypted to some of the public APIs here. But you can also go, if you're behind a proxy, that works as well. Or again, if you have a VPN or express route, you can also go through that using private endpoints. So in my case, I'm going with the public connectivity in this case, and then you can see here we give you some pre-redefined tags you could use if you want to, but you can also define your own. And at the end, you get basically that script, which will help you onboard that server. So you would just basically download this or copy paste it on the server, and this will then install the agent. Now, to give you some more background on this, let's go quickly to my server here. So here's my server. If I look at hostname, you will see this is app01. And I already installed the agent here and registered it. So if I do that, I get this new process here running. This is basically the hybrid machine agent, which runs in the background. And then by installing that, I also get a new CLI called the Azure Connected Machine Agent tooling. So if I hit that, you can see here I get some available commands here. So one of them is to connect. That's obviously the one I run to connect the machine. But then I get also some additional information. So what I can do here is the show command. And you will see a couple of things here. Obviously, I see the status. I see like, okay, what is the Azure resource name for that server now? Again, this server is not running in Azure. This one is running here in my local data center underneath my desk. You can see where it is in this resource group, subscription, tenant. It also has a VM ID. That's very important because what happens now is when you install the Azure Arc machine, Azure Connected Machine Agent, you will not just get like all these management capabilities, but the server itself will now get a managed identity within Azure Active Directory. So you can now set permissions as you can do for Azure Virtual Machines. So your apps can take advantage of that. So you don't need to store like passwords anymore on your machine or anything if you need to, for example, have access to Azure Key Vault or even to other applications. You can see like which services have installed, which version, and so on, and how the agent health is. So when you install that agent, after a couple of seconds, close this. Come on, close this. It will show up here. So you can see here, this is my app01 here. It shows up. You can see here that this here, for example, now looks like an Azure resource, right? Again, join to a description, join to a resource group. You can also find some additional information here, what type of operating system it is. And you can see here, this one is, for example, even domain joined to a local domain. It doesn't need to be that way, but this server just is. So this is a possibility. You can see here, I have tagging here as well. And then on the left side, you see that you get all these Azure features like an activity log to see, okay, who did changes to that machine or to these settings. I can see that I have access control, so meaning role-based access control to make sure that like I can say, okay, in Azure Active Directory, who or which group has access to it. And then you can see I get some additional management capabilities. And to let me show you that, I want to show you that in this server here. So first of all, you get, for example, Security Center. So you can enable Security Center and you can then see all the threats we have here, different stuff I need to do with like ratings from low to high. I can, for example, go out and manage extensions here. So extensions are a pretty cool thing. You know that probably from Azure VMs. So what I can do here is I can deploy an extension. This can, for example, be a custom script extension. And then I could just go out and run a script against that specific server, even though it doesn't run in Azure. So that is pretty cool, but there's obviously more. So one thing, I have access to log analytics. So I can actually run queries. So I can see, for example, in this one, I just run like a query to see all the security events on that specific server. So this will give me all the security events happen on that server. Again, this is obviously also something Azure Security Center takes advantage of it. And I can also forward that to Azure Sentinel as well. So I get that single view. I can also go and obviously look at monitoring with these logs. We also get monitoring capabilities. So first thing I want to show you here is that I get like basically disk performance, disk CPU utilization, availability, memory utilization, disk utilization in terms of bandwidth, IOPS, and all the good stuff you need also for networking. So that is pretty awesome. Then you also can enable the dependency map. So this helps you actually see where is that server connecting to. and what is connecting to that server. So you can see here, okay, these local IPs are connecting to that server. That server connects to different different ports to different endpoints. So if you go, for example, to port 443, if I zoom in here a little bit, you can see here where is actually connecting, and then you can see that there's also, for example, the Azure Arc endpoint here. So this is the Azure Arc agent running on that machine connecting, but obviously everything shows up in this log here, so you can see what happens and where is this server connecting to. So pretty helpful if you're doing troubleshooting or if you do migrations and stuff like that. You can also enable tooling like change tracking, so we can see what changes are happening. We can do inventory. You can scroll through the software inventory of that machine. So this one, for example, I know has Windows Admin Center installed. So you can see here, if I search for it, I find that software. I can actually see what's installed. And then I can also go and have a look at update management. So if I click on update management here, you will see that I'm not in a not compliant state because I have missing updates here, especially security updates. And now I can just simply go and change that by triggering an update deployment. So I could give that a name. I can then define a maintenance window, reboot option, and schedule that update deployment. I can say update now. This will then trigger it into 5 to 10 minutes. However, I'm still in the presentation, so that's probably not a good idea. And many of you probably want to do that outside of business hours. So I could go and schedule that update deployment, that I can even making a recurring task if I need to, and say let's patch that server every Thursday night, right? You can then select what updates are getting installed. You can run a pre and a post script, and at the end you would just create that update deployment job to deploy that. Now you probably say, Thomas, okay, this is great, but I have hundreds of servers, or even if I have 10 of servers, I don't want to do that per server, right? So yes, you can still go and select manage multiple machines, and this will take you to the Azure Automation account. And here you can see then all the machines which are managed by this update management. Again, Linux machines, Windows machines, running in Azure, running outside of Azure, virtual machines, physical machines. So basically everything. And then I can also schedule an update deployment job here. With the only difference being here now, I can create an update deployment job for a group of servers. So this is going to be great to manage updates for your servers. Doesn't matter where they're running. You can actually do that centralized from Azure using Azure Arc and Azure Update Management. So the other thing I want to talk about is actually Kubernetes clusters, right? I talk now a lot about servers, but obviously it's not just about servers. You also have maybe Kubernetes clusters in your environment. So I have added a couple of Kubernetes clusters. Again, these are running outside of Azure. Those are not Azure Kubernetes clusters, but they now show up in Azure and they become a native Azure resource. Now, if I have a look at this server here, this Kubernetes cluster, you can see here again, I get monitoring. So let me see if I enabled monitoring, I'm not 100% sure. You can see here I get monitoring for that Kubernetes cluster, all the good stuff, nodes. I can also monitor my containers running on that cluster as well. So I can see what's going on here. I can go out, for example, to my notes as well. So I can see all that, what is going on. You could also log analytics. I can also use policies like the things I showed you before with servers. You can also do that for that as well. You have extensions, you have security center. But one thing I want to show you is actually GitOps. Now, think about you want to deploy or manage your Kubernetes clusters, especially at a certain scale, right? You need to go out and do that for every single server. Now, what we can do here, we can use GitOps to actually go out and deploy a configuration. So I already deployed a configuration here. It's called the Hello Arc application. And what I did is basically I stored here on the bottom the application configuration inside a Git repo, right? So this is a public one, could also be a private one. And then I said basically, hey, deploy this to my Kubernetes cluster. And so if I look at the application here, so this is the application running. So it says Hello Azure, right? So I can, for example, run that application here. And then let's change this, right? So if I go into my Git repo, I can actually find this configuration file here where I also can change the message. So again, don't do that at home. I'm going to do this like in production in my environment, just checking into the main branch, just doing an edit. So again, don't do that at home. This is just for demo purposes only. I'm still gonna do commit the change message because I'm a good admin. But again, I'm going to directly commit to my main branch here and connect that. And then basically I did this change now. Again, you can also absolutely work with multiple branches. You can work with approval processes, and that's what you should do. But just for the demo purpose, I just did that here. So if you're going to go back in this configuration, you can see here, this Arc agent deployed to that Kubernetes cluster, this configuration, pulls like that GitHub repository for changes every 3 seconds, right? That's probably a little bit lot for production environments, but for demos, it's actually great. So if I go now back to my application, and if I do a refresh, you can now see it says, hello, PDC Conf. So this is how I can then do changes to the application. You could see that I cannot just change this message, right? I can basically do all the changes to the application. So if I have a new version, I can roll that out. And now you would say, basically, Thomas, this is great, but like if I have one Kubernetes cluster as well, yeah. I mean, it's still great to deploy to that. I mean, I don't even need personal network access to that Kubernetes cluster, right? I can just do that and still write my code, and it automatically deploys to that. But think about if you have not just one Kubernetes cluster, if you have actually multiple Kubernetes clusters. If I now update that application, I could like easily deploy this to hundreds of Kubernetes clusters out there. So that is pretty cool stuff. So let me show you. Let me go quickly back to the slides. So to like summarize what I just showed you. So one thing I want to highlight here is the Azure Arc enabled servers. So you saw how you can get an overview, how you can actually manage Linux and Windows, VMs and physical machines, completely domain agnostic. You can organize them. You can start to take advantage of security features like Security Center, update management, policies, and then you get also role-based access control to these machines. Similar, we have Azure Arc enabled Kubernetes, which basically can also take advantage of all that good stuff. Especially highlight here, I wanted also the Azure monitoring experience, the configuration task, like using the GitOps workflows, getting security insights, getting all that governance done, but then also have, for example, a CLI, which I didn't show you yet, which allows you to connect that Kubernetes cluster. So if you need to run some kubectl commands, for example, to that Kubernetes cluster, and you don't have network access, you can do that through Azure if you wanted to. So this is pretty cool as well. And so going back to this slide here, I spoke now a lot about Azure Arc enabled infrastructure and how you can actually onboard these existing resources to Azure, right? But now let's have a quick look at Azure Arc enabled services and what that means to bring actually Azure services to any infrastructure. So very simple here. One of the services we have, which you can deploy today in preview, is Azure Application Services. So you can go out today and actually go out and deploy app services, function, logic apps, API management, event grid outside of Azure, right? So if you want to run Azure functions out of Azure, this is one of the easiest way to do so. If you want to run logic apps outside of Azure, in your own data center or even at another cloud provider, you can do it using it with Azure Arc enabled app services. So I'm going to show you a little bit how that works, right? So I'm going to back quickly to the portal, like how do we do that? So if I go back to Azure Arc, now I spoke a lot about the infrastructure part over here, but now let's talk about the services part down here. So you can see here, I don't just have like the app service part, as you can see here. I also have, for example, the SQL part. I will talk about that in just a minute. But what I can do here is I can actually, when I deploy something, I want to not just deploy it to an Azure region, I want to deploy it in my own data center. And that is where custom locations come in. So if I click on this thing called custom locations, I already did a setup. So what I need for a custom location is a Kubernetes cluster joined to Azure Arc. So I took one or two of these Kubernetes clusters here, which are running outside of Azure. I just showed you that before. For example, one of them I managed using Azure Arc enabled Kubernetes. And one of them is running at another cloud provider. And one of them, as you can see here, is called Tom's Data Center 01. So if I now go and want to deploy a new app service here, if I click on create, I basically need to select a resource group, a subscription, again, like a heavy Azure service. But then instead, like where I choose an Azure region, so if I open this up and select Azure region, I can just scroll up here, and instead of just having Azure regions, I now have something called custom locations. So you can see here Tom's Data Center 01 and other cloud providers 01. Those do not sound like Azure regions, right? Those are my custom locations. So if I then want to deploy that app service, for example, to my local on-premise location, I can just select that. And you can see here also the URL changes, obviously, but then you can go through that wizard. And again, this is not, I show you this in the portal, but even if you use ARM templates, if you use Bicep, if you use the CLI to deploy stuff, if you use tooling, native tooling in Visual Studio Code, for example, you can also take advantage of that, right? So it's not just the portal, but the portal makes it easy to show stuff. So this is how we deal with that. And then I want to quickly hop back and talk about this. So what does that help me with? So obviously this helps me now in a couple of different things. If I build applications now, I can take advantage of these PaaS services wherever we are. That means I don't need to build an application like where I can take advantage of Azure PaaS services when I run them in Azure, but if I'm running outside of Azure, I can't. With Azure Arc, I can actually do that with both locations. So that is awesome. And then obviously, well, we don't just need like app service. We obviously also, for our application, we often need databases in the background. So with Azure Arc enabled data services, we can actually deploy Azure SQL managed instance and Postgres hyperscale to these locations as well. And they're not just a Microsoft SQL database. They actually deployed as the Azure SQL service, if you will. So you get all that automation built in, taking advantage of automated updates, and so it's a service. You don't need to go out and actually patch these manually. And the great thing with Azure Arc enabled data services, they're available in connected mode, so meaning that you have a constant connection to Azure, but you don't rely on it. So even if there's an interruption, that doesn't matter. But then you can even deploy this in disconnected modes as well. And then this obviously now is makes a point what I just said. It gives application developers, architects, IT pros the flexibility or convenience of using the existing tools and practices they have to deploy and create and manage applications, but then extend this. So you can do that like whenever this is running on premises or at other cloud providers. You can then take advantage of Azure Arc enabled infrastructures to manage your servers or your Kubernetes clusters and deploy through them using DevOps techniques, for example. But then you also get the Azure Arc enabled services such as data services or application services on top of that, where you then can build like these hybrid and multi-cloud architectures, which is pretty awesome. One thing I want to mention is if you don't want to run that Kubernetes cluster yourself in your own location, but you still want to take advantage of these data services, we also offer something called AKS on Azure Stack HCI. So in that case, we have obviously our Azure Stack hyper-converged infrastructure offering running on hardware in your own data center or edge locations. You can then run the Windows or Linux VMs, and on that you can then run different applications, right? However, we also offer, again, our Azure Kubernetes service on Azure Stack HCI, meaning that you can now run AKS outside of Azure in your own data center. And this comes then again as a managed service, if you will. So you can actually then run containers on top of it as you would do with AKS in Azure. And then you can also use Azure Arc enabled services as the things I just showed you to deploy then your cloud native applications as well. So that is pretty awesome. So if you want to build that and you don't want to set up all the Kubernetes stuff yourself in your own data center, that is where Azure Stack HCI and AKS on Azure Stack HCI can help you with. And then all that is obviously managed or can be managed through Azure Arc. So last but not least, if you want to learn more about building these hybrid and multi-cloud applications, managing these environments, basically understanding what the approach is, we have some great resources out there. So one of them I want to highlight is definitely the Cloud Adoption Framework. So what we have there is resources and a special scenario guide for multi and hybrid cloud integration, where we actually outline especially the control plane part, but also the services part. So basically a deep dive in all what I just talked about, and you get some more information there as well for you to read. We also have some great Microsoft Learn modules. So you can actually go to microsoft.com/learn, where you can learn more about Azure Arc, but also a ton of other Azure and non-Azure technologies, and even not just technology, but really a lot of different learning things we have. We have some great hybrid reference architectures in the Architecture Center. So there's some great stuff there. I also put some links here to the documentation, so you can go out and check this out. I also highlight that you can go out and use the Azure Arc Jumpstart project. That actually helps you to go out and quickly try out these Azure Arc enabled features. We're built on a lot of automation there as well. So with that, I want to take advantage and say thank you very much for this presentation today, for following that. If you have any questions, please feel free to reach out to me. We can then figure out how I can help you. Again, there's more resources coming. There's always updates coming to our services. We have new features in the pipeline for our hybrid environments, obviously. And so please feel free to reach out. And with that, I want to say thank you very much for joining PDC Conf, as well as my session today. Thank you.
Techaholic was conceptualized in mid-2018 as an open community platform. Techaholic connects industry professionals, vertical experts, and learners together, bringing real-world relevance and career exposure for enhanced learning. Our vision is to enable professionals and organizations to achieve more through the community collaboration. Our mission is to nurture industry-ready professionals who can enhance nosiness outcomes with skills on upcoming technology landscape. And our values are to make everyone shine. by sharing our knowledge, bringing honor to individuals, encouraging innovation by using the latest technology, networking to enhance collaboration, and encouraging excellence in technology-enabled solutions. We are creating communities with the motto of Go Far, Go Together. We empower individuals to achieve more through their skills without worrying about anything else. We help our community members to become industry-renowned, self-dependent professionals. To achieve industry recognitions, you can join our community to work with our existing industry-renowned community leaders. Our community leaders could mentor you and provide the stage to work with local and global communities. Mentors can lead you to the next level of growth. Techaholic empowers individuals to achieve their career aspirations by connecting them with the right mentors who are proven industry veterans and subject matter experts. Internships help you with real-world experience. Today's students are tomorrow's leaders, so we will not leave you alone. We have open internship programs to onboard technology enthusiastic students through formal process. Lead your digital transformation assisted by our industry veterans and technology community experts. Our designs are centered around business and technical requirements. We optimize your cloud designs to enhance administration and user experience. We secure your cloud with defense in depth. We provide guidance on cloud governance and compliance. Techaholic can also help you solve problems like lack of flexibility in capacity and cost optimizations, time to execute, efficient remote working, and infrastructure monitoring. Techaholic is making it easier for both freelancers and organizations by inventing a new way of working with freelancers globally. As a freelancer, you can choose your assignments either through your own network or through our network. We take care of all the onboarding tasks so that you only focus on your assignment. We are continuously growing our community to help individuals and organizations in capability building with skill-based learning. In the ever-changing job roles, we are extending the learning outreach by nurturing the future-ready and most desired professionals in the industry. We bring together a large array of technology professionals with varied industrial accreditations, eager to help build enterprise solutions and enable the learners. Now let's look at some of the popular industry certification courses offered by Techaholic.
Hello, good afternoon, good morning, good evening, depending on where you are. How are you doing? Are you enjoying the PowerShell, DevOps, and Cloud conference? I hope so. I hope that you are acquiring a lot of knowledge and that you are pretty excited about the next topics. So my name is Luis. I am a Microsoft MVP in AI and developer technologies from Mexico, although I am based right now in Czech Republic because of my PhD studies. And today I am honored to talk about serverless image recognition in WhatsApp chatbot with Azure AI. So please feel free to post your questions in the chat, and I will do my best to try to answer them. So before we get started, we thank you and we appreciate the effort of all the sponsors for bringing this type of events and encouraging attendees to learn and to come to join us in this excellent conference. So thank you very much. And of course, also thank you to you that you are here. So yeah, as I was saying, this is today's topic. We are going to talk about artificial intelligence. We are going to talk about programming and also Azure functions for the serverless part. So here you have my name. You also have my contact details, Twitter, LinkedIn, in case you would like to get in touch later about these topics. Or I also enjoy developing cloud and mobile applications. So these topics are quite joyful for me. So yeah, feel free to contact me. All right. So we are going to start with a brief description of chatbots. Then we will talk about artificial intelligence in two parts: natural language processing with a cloud service or cognitive service, and then the image analysis under computer vision field. After that, we will explain about some APIs to access WhatsApp. And of course, we are going to talk how to integrate everything together with Azure functions, and we will demonstrate all the project. But in every topic, we are going to cover some of the practical part. All right. So let's see. First of all, we are going to talk about chatbots. Most probably, we have already interact with a digital assistant or with a software which engage in a conversation with us. This program behaves like a human in the sense that it uses some language, natural language, right? Maybe English, Spanish, any other language. It uses the same vocabulary or words with us, so we can understand. And we can talk or type some messages to this bot, to this conversational bot, in the same way that we would do it with a person, with a friend. So we don't need to, as users, we don't need to use special commands. We can just ask, for example, is it going to rain later tonight? Or I would like to book a reservation for a hotel in Rome from October 1st till October 8th. And then this assistant, this bot, will process the message and will try to detect the intention. What is our purpose of this message? And of course, reply in some logical way. Like, okay, if it understands what we mean and gets the context, for instance, if I was asking about the weather, it will understand, okay, when and where, like today and from here, right, from Czech Republic maybe. Or if I am booking a hotel reservation, well, it will detect the dates, okay? And will maybe make a search on a database and will present information to us, okay? So this sounds a bit, let's say, challenging, of course, because how can some programmer, some data scientist, someone program such advanced software, right? That understands whatever we say, right? So yeah, we will talk about it, but we briefly describe how a chatbot works. So the key is the message and the context, because in the message there is an intention, there is a purpose of this conversation, right? So this software has to process this text. We can even speak to it because, you know, there is Alexa, there is Cortana, Siri, and other digital assistants. And it's the same. We can speak to it. It will make an extra step, of course, which is the conversion of speech to text. And then it will start analyzing the text to detect what we said earlier, right? The intention, the context, right? And after that, compose a reply that makes sense to what we asked at the beginning, okay? And of course, since it's a software, it is easy, or it is easier for these machines, for this software, to combine thousands, millions of data, because, you know, computers can calculate or compute a lot of process faster than us. And okay, if depending on the code, it can even connect to different sources, right? Also, the advantage is that, well, it is available all the time, or it can be available all the time, 24/7, 365. And it is quite common that they are integrated in different platforms, web, mobile, even some applications such as Facebook, WhatsApp, Teams, and others. And depending, of course, on how it is built, it can improve the user experience in order to keep human effort to the minimum. And yeah, this is important. And this is one common use case scenario for bots. Maybe there is a customer center when some employee is receiving calls from clients and they have problems with their computers, right? And maybe in 80-90% of the cases, they are quite common problems, such as, okay, my computer is not starting. Okay, so there is some wizard, there is some procedure. Maybe even these employees already have a manual right? Okay, is your computer turned on? Is the, I don't know, the computer, is there any energy, any power? Do you see the Windows logo, right? And maybe 80% fall in these known cases. So these repetitive tasks can be assigned to a bot, to a program that, of course, extracts the keywords in order to maybe detect the problem and then recommend different steps in order to solve this issue from the user. So it is a good candidate to implement a bot when there are solutions that are simple and repetitive. And in the remaining 20% of the cases, when there is a specific, or maybe the problem is unknown, we can always call the person, the employee, right? Maybe the employee will be assigned to another task where their knowledge or their experience will be more useful, rather than just replying to customer calls, right? As we said, we will improve not only the customer but also the employee experience. And in these 20% of cases, the employee will directly interact with the customer, because this problem is quite specific, quite hard. So yeah, it is possible, because bots, maybe they don't solve everything, but most of the cases. All right. So we get to this idea that we described earlier. How is it possible that if we have some message, such as turn on the lights for kitchen, how is it possible that it can detect what the user means? What is the intent? The intent is, okay, turn the lights on. And the context can be known as entities. Okay, where? Kitchen, room. Okay, the room, but it can be the living room, it can be the garage, it can be my bedroom, other things, right? It's like a variable. But the idea is, okay, turn the lights on of some specific place. Even here, because if I don't provide this context, the bot can understand, okay, turns the light on wherever the user is, right? Because, well, if this is connected to a mobile application or a web browser, it is quite easy to get the GP, or to use a GPS, right? To obtain the location of the person. So this is part of the natural language processing or text processing. Of course, we can implement a neural network. We can train it to understand this type of interactions. But nowadays, there are some cloud services which help us to build bots or the text processing part easier by providing some samples or utterances, right? Because maybe another example for the same intention could be, could you please turn on the lights for the kitchen? And others, right? So yeah, we can provide different examples. And that's the idea behind a cognitive service created by Microsoft, or an already trained, right? Which is known as Language Understanding Intelligence Service, or LUIS for friends. So the idea, as the name suggests, is that it will process text, natural language actually. It is a cloud-based service, simple to use, simple to integrate, and you don't need any previous AI experience to use it. As I always say, cognitive services help you to reduce the AI problem and make it a programming issue or problem, right? Rather than an artificial intelligence one. So it is easier because, well, many of us can program, can write code, correct? So we can send some requests. So how does it work? Basically, and I think I can explain this with the website. So we go to the website, luis.ai. And here, we need now an Azure account. And after that, we create a project. When we create a project, we are getting a workspace where, in my case, the name of the project or application is this one, WeatherBot. I will, make this larger. Okay, here it is, WeatherBot. And a second. Here I can create intents. As you saw in the slides, like turn on the lights, I can name it whatever I want. In this case, I have an intent, get city weather. And I can also create entities. For instance, if I want to know the weather of a specific city, one entity could be the city itself or some place in general, right? This is known as geography version 2. This geography version 2, it's actually a pre-built entity. It is already there. In this case, this service contains some pre-built entities such as date and time, also numbers. And it is quite powerful because, for instance, in numbers, it includes digits. It includes numbers with letters, or also, of course, with digits, and even positions like first, second, third. That's also a number, so it can detect it inside a text. So this geography version 2, it detects cities, continents. Okay, so yeah, and after I create the intent and the entity, I can access the intent and provide several examples or utterances. And you see here, for instance, I have already provided this example. Is it snowing in Seattle right now? What is the current climate in Cortázar, which is the place where I live in Mexico? Is it raining in London? Can you tell me the temperature in Prague? And some other examples. And please check or see that the place is either detected, or I can just click on the word or words and identify or tag them as entities. Okay, in this case, geography version 2. If I had some other entities such as product, and of course I provide the name of the product such as chocolates or sugar, milk, and others, I can also do the same. And after I provide enough examples of this intent and maybe other intents, I can click on this button, train, and it will start building a model, right? With these examples, it will start training, right? So the idea is after that, this model can be published and make it available for applications. It will actually create an endpoint. So we can send some requests, right, to this endpoint by providing the text that we want to process, right? I can also, of course, test it here. For instance, I want to know the temperature in, I don't know, I would say China. Okay. And you can see, well, of course, it detects that the intention is get city weather, because I also have one, but there is also known, but okay. And if I inspect, I see that the the entity, it's China, right? But actually, this gets a JSON response. I can see it here. And this is what makes it available to use it or implement it in our own programs, right? Because if I now go to the software, right? This is a specific type of project, but I will not say which type of project yet. But in this case, I have a Luis service class. It's my own class, okay? I provide this URL. This is the endpoint that I mentioned. You can find this endpoint here under the settings or of this project. Just a second. Under manage. I will see the application ID and also some published settings. Or maybe check, let me check the, okay, yeah, here. It will appear here. Yeah, this is the endpoint. Well, it includes an example query, but here you can see the endpoint. And this is the one that I use here. You can see that at the end, well, not at the end, but here, I append a query, which is a text. This method actually, of course, adds some text, which is the one that we are going to receive later in WhatsApp or whatever program. It will send an HTTP request, post request actually. And if the top intent is get city weather, it will try to detect if there is an entity of type geography. If so, I will return this value, this entity, because my object of interest is the city or some place, right? And I will use this place to later send it to another service, which is Open Weather Map service. Open Weather Map is an API. It has both free and with price or with cost service. I am using the free version. Again, I use the API. And after that, I pass down this city. I send the request and I get a response with which information. You can see here the model. Maybe the temperature, if it is cloudy, the wind speed, and other data which might be useful, right, for some weather application. Yeah, so you can see how I can connect or even the natural language processing part. It is done by this service, by this Luis service, which you train at the beginning. Then it will be where we want to connect or integrate this, let's say, feature or this functionality. Okay. So yeah. And well, as you can see, I don't use any in my code, any artificial intelligence library or neural network or whatever, or no. It's just HTTP request, which is programming. You can do it in C#, in Node.js, JavaScript, PHP, any language that you want, right? All you need is to provide, of course, or send the request in the right way, right? With the body, header, and so on. So yeah. So I explained this to you already. And yeah, we use the endpoint and we go to the program. I already mentioned you about the weather API. Just go to openweathermap.org/API and you will see what it offers. Okay. So next, okay, I see a question. I think I can answer it right now because it is according to this topic. It says, thank you for your question, first of all. It says, is there a way Luis endpoints can record all the incoming strings from application and use it for automated retraining? Okay, that's an interesting question. Thank you very much. Well, to be honest, I don't know. I know that other service such as Custom Vision does it, but for Luis, I'm not sure. But of course, you can always save it. Let's say in your program. Maybe I here right every time I receive a message. I mean, I will do it on my own, right? And then I can store this text in some other place. Also see what was the result, what was the intent, and later I perform a manual retraining. I know what you mean, but let me tell you that on its own, it cannot build or generate another model unless we tell it to do it, because there is also an SDK. Because of course we can also maybe create some Azure function or some program that runs every day or every weekend that takes this collection of text and create a model, right? A new model. But we should always test it. We should always check if the model is correct or not, or if it needs retraining, or if it needs more examples, more utterances, or whatever. So on this side, let's say, we cannot just leave it to create a model automatically. We need some check from our side. Okay. So yeah, I can maybe later check if it if I can see what was the text that were provided by users, right? I would say no. I mean, I think it doesn't, but of course we can save it on our own. Okay. Let me know if this answers your question. If not, just send an email and we can chat or we can talk about it later. Okay. Thank you. So let's move now to the computer vision part. Computer vision is also a relevant area in artificial intelligence, which focuses on bringing some sight to applications. So maybe some software can see what is happening around the world, right? And try to understand what is happening. So maybe detecting that there are some objects and what they mean. Not only that, it can also detect a specific or relevant information such as brands or even text and perform a task known as optical character recognition, right? Every character means something and you can see it there. Object detection, okay, find me in this picture all the buildings. So how does it work, or how is it built actually? It's basically neural networks, which of course you provide previously hundreds or thousands of samples of maybe pictures where there are buildings, and we told the neural network, okay, here in this part there is a building, right? This is known as supervised learning, because you provide a picture and then we say, okay, here this is the relevant object. Okay, so the neural network will understand or will detect some pattern. What is the definition of a building? What makes it a building, right? Is it the shape? Is it the, I don't know, some edges, some specific parts? Right? It will detect this pattern. And the same goes for brands, even face detection, of course, and characters. And one more advanced task in computer vision is the image description or image analysis, which means that it can describe what is happening, right? In this picture, each of us can say different things, right? Maybe someone is focusing on the taxis. Some other person might focus on the person and the dog. Some other person just focus, okay, there are a lot of buildings. Maybe some of you can even detect the city, right? So, and this is correct, right? Depending on the point of view. So this is a powerful task to generate a description. And in this case, it involves all the tags, all the objects, and how they are connected. Again, if we would like to use or implement this in a software, in a program, yeah, we need to build a neural network, or we can rely on cloud services. Again, Azure has a cognitive service, computer vision, and in this case, we provide a photo, a picture, an image, and it will give you a JSON with the information that you need. In this case, I also have another program. Of course, in this case, in order to use this computer vision, I need to set up a cognitive service resource. In my case, I have already done it. This is a cognitive service, right? Resource on Azure. And here, I can just get the key and endpoint. The endpoint, of course, is where I'm going to send the request, and the keys is to measure my request, because there is a free layer, but also some pricing, and there are some limits, okay? So here I have my key. You see it starts with, it starts with DE9. So this is the one that I am using here, right? DE9. And I have my endpoint. Then, with very few lines of code, okay, I first create some client for this endpoint. I am using a library or NuGet package, which is the Microsoft Azure Cognitive Services Vision. Here you can see it, computer vision, right? This is an SDK, but of course you can implement it in JavaScript, right? And if there is no SDK, you can always send a direct request to this endpoint, correct? And after that, we use this method. Okay, I created this method, analyze image URL. I send some picture or pass down some features. Okay, I want you to detect some categories, faces, if there is any tags and other things, even a description. We send the URL of the picture that we want to analyze, and we get a quite huge JSON with information, which includes descriptions, categories, tags, objects, brands, even celebrities, right? And it's quite easy to get this information, right? So yeah, that's it. And we will see it, of course, working a bit later, okay? So again, just code. Then we have WhatsApp. I will not take too much time here, because maybe all of us know what is WhatsApp. It's a messaging application, maybe the most used one, along with Facebook Messenger, but they're part of the same umbrella, or yeah. Every year, every month, every day, there are new users of WhatsApp, and billions of messages generated every day. Even every minute, there are quite a lot of data or messages that are generated. So yeah, it is important to maybe consider it as a way to communicate with customers, right? WhatsApp has a business part, which helps companies to quickly send messages to customers, maybe some already pre-built messages, or you can, as soon as some user reaches your, let's say, a conversation with you, it can give the user some options or present some menu, or, okay, this is the hot sale for today, right? In order to accelerate the communication. So there is an API that we can use to create programs. But in order to use this API, actually WhatsApp doesn't have a public API. There are always some projects, right, done by third parties or by some smart developers, but they are not official. And most of the time when WhatsApp updates the version, these APIs need to make some changes in order to adjust, right? And sometimes it might not be easy because maybe there are some break changes, okay? There are also some partners which we can access from Facebook, and they already have, let's say, official access to the API, but we go with the partner. And in this case, Twilio, it's a cloud communication platform as a service, which you can use to send text messages in your program. You can create a C# application, Node.js application, and send a message, an SMS message to the user. You can create virtual numbers. You can even make video calls. And you can also send WhatsApp messages, okay? WhatsApp is part of Twilio API that with very few lines of code and by using TwyML structure, which is basically XML, it's a markup language, you can get or receive messages from a conversation. This slide is not accurate because now it's not currently, it's already available on Twilio, right? And you can test in a sandbox environment, and you will see in a second. So in this case, and I think I can go directly because time is running. So in my case, I go already to the dashboard, Twilio dashboard. And here, of course, I am already here on WhatsApp. And let me refresh this page. And as you can see, it says, okay, we can access a sandbox. So you need to add a phone number. In this case, I have already added it. Here you have it. Okay, let me check. Yeah, this number, it's the one that is saying here in my account. By the way, you can create an account and you can get free credits after you register for this. So I have not spent any penny, let's say, to use this or to build this. So, okay, in my case, it says, in order to join this sandbox, you need to send a message. I am already typing it. It's this one. Because, okay, yeah, it says, okay, join this number with the code. I will send it, and it will detect it here. It says message received, so you are connected, right? So then we can test, we can send some message from this dashboard. I will not do it because that's not the focus, that's not what I mean. But I want that if the user types something, right, a process is triggered, some analysis. So this is the chatbot part. If I say something like, okay, what is the weather in, weather in Sling, for instance, which is where I live. I will not hit enter. I will not send it yet. But my objective is that if I type this message, it will get processed, right? It will get analyzed. And here in this part, I'm not sure why it is taking too much, but no problem. I can get back to this. But here, there is a webhook which I can connect. Here it says, when a message comes in, I can provide a URL that will take the message and will do something with it, right? So yeah, of course, I have not mentioned this part, and this is the next that I'm going to explain, right? But here in Twilio, okay, you can see that, okay, I have created the account, and then I activate the sandbox, join it, and in my code, I have this at some point, right? I have, okay, let's receive some message. This data contains all the whatever the user types, and after that, just some small processing of the string. And here there is some analysis. If this form or values contains a new media element, it means it's an image, right? Oh, sorry, if the new media value is 1 or 2 or whatever, it's an image. So if it is an image, it will call the computer vision service. It will process the picture. And fortunately, this picture has a URL. So we don't have to send a stream or whatever, just the URL. And if it is a text, it will process, or it will call the LUIS service, which I mentioned earlier, right? And after that, it will build a TWI-ML message. In this case, I also use the library, which is Microsoft Azure WebJox Extensions Twilio, so I don't need to build it manually. I just create a message in response object and send the message, and that's it, right? So yeah, that's the idea. This is the code that is going to be executed, but the problem is, or the question is, where is this code, or where is this assembly, let's say, stored, so it can be called by WhatsApp, right? So this is where Azure Functions comes in. Azure Functions, it's your code in the cloud. Okay, basically, it's like a web service that you have, let's say, running in some server. But actually, you as developer don't worry about the server. You don't have to provision a specific memory, amount of memory, or specific resources. Azure takes care of it. So you don't worry. You forget, let's say, about the servers. And this code, this classes program that you have there, this project or solution, right, will run under specific circumstances when an event happens. So it is event driven, right? So when, for instance, an HTTP post request is sent, or when, in this example, I also have another one, when I send a picture and post it or upload it to a blob storage, there is something called blob storage trigger, right? So when a new document or file comes into my blob storage container, it will perform some code. It will execute some code, right? Or maybe every hour, there is a timer trigger, right? So there are different triggers that can automatically execute some code when the event occurs, right? And the code is also simple. For instance, you know that there is an SDK to connect to the blob storage, but you actually just parameterize the function, your Azure function. You say, okay, this is the path, this is the location of my storage account, this is my connection string. And in the code, you simply use the byte array or some stream, and that's it. And you can see that these are known as bindings. There are some input bindings, which means that you read the data, and there are output bindings, which means you write the data or something. And I already explained you this code, right, which gets the WhatsApp message and process it if it is either text or image. Well, this code or this project is actually an Azure Functions project, right? So yeah, and I can publish it to Azure, right? I can even deploy it to other clouds or even to a container, right? So, well, in Visual Studio, it's quite easy to publish it. It's just a wizard. And after that, I will get a URL function, a public one, right? So this one, you can see it here, but I think it will take some time. So yeah, yeah. So you will get this URL, which you connect or add it here in the sandbox. And after that, it will process text or images. And this is demo time, okay? So let's do it. Now I will send a text, right? And as you see, I will get a reply, right? The weather of the scene is clouds. Right now it's cloudy. And I can also send a picture. So I will send a picture of me, right? And you will see a lot of information there, here. Because, of course, that's what I wrote in the code. A man wearing glasses with some confidence, people, human face, person, wall, human bird, right? You see different objects that are detected there. But it can also detect some celebrities. So in this case, well, if you are excited about some new movie that is coming in later this year, you see that actually it detected it's this famous actor, Alfred Molina, right? And finally, I think I have just one final example. Yeah, this one. Let's see. Yeah, it's a cat, a close-up of a cat with some confidence and so on, right? And again, is what is the climate in, I don't know, Tokyo. And yeah, we should get some response. Okay, for some reason it's not working. You know, the demos are sometimes slow. Okay, whatever. So yeah, basically, and with this I finish because there is a small time. You see how everything is integrated. Some picture or some message is processed by Twilio because this is part of the WhatsApp element. Then Twilio calls the Azure function, and if it is text, it will use the LUIS service. If it is an image, it will use computer vision service. And after that, you will get a reply, which is in number 5, and you will send it back to the user. So yeah, that will be all from me. This is just some slide where you can learn about it. I wrote a post, actually 2, but one is in Spanish, the other one is in English, right? And there are some tutorials on Twilio's blog. And also, yeah, actually this other one is also on Twilio, okay? So yeah, that will be all from me. Thank you very much. If there are any questions, I will do my best to try to answer them. answer, right? Okay, we have the request to do automated retraining, but I think what you said makes sense by using any serverless function to periodically run the retraining. Yeah, exactly. You can even create another action function for as a timer trigger, right? And use the Luis SDK, generate a model, but of course, you have to test it. Or you can even build some unit testing, right? Okay, this is the message, this is the text, and this is the expected output, right? And you can compare it to what the model says. And you can create different tests, and if they are correct, if you have pretty good accuracy, maybe you can say, okay, this is the new model, and this is the publish. I'm going to publish it. Okay. Thank you for your question. Okay, so I think there are no more questions.
Hi, everybody. Hope you can hear me. Cool, let's get started. Thank you for having me. My name is Sriram Bhargav. I am joining from Sydney, Australia, where we are currently in lockdown, and it is fantastic to be able to join the PDC conference and listen to some really technically engaging sessions. And let us get started. Let me share my screen and we'll get started very soon. Today's session, ladies and gentlemen, we'll just quickly cover what is hyperautomation. There's a lot of hype about AI and machine learning and stuff like that. So let's try and de-jargonize and demystify a little and understand, is it really hype or reality? Then we'll go right into use cases where AI is really in action when it really matters, especially during the COVID situation here in Australia specifically. We'll cover about specifically a use case where freight and logistics, the end-to-end invoice reconciliation is done. This has been done using the Azure serverless components and the cognitive services and the machine learning layers in Azure. It's a brilliant end-to-end hyperautomation use case. I'll share some lessons learned. Not everything should be good, but some of the lessons learned and then some of the best practices. So let's get right in. Let's first look at what is hyperautomation. Right? There's a lot of buzz around hyperautomation. Everybody talks about automation, AI, RPA. I mean, you name every technology company is talking about it. But typically, what is hyperautomation and why all this buzz right now? I know from the last 10 years, we've all been hearing about RPA. RPA predominantly is used for manual and repetitive processes. It's very less human judgment, predominantly rules based, mundane and structured. For data gathering, reporting, reconciliations, validations, copy paste activities, web scraping kind of activities, RPA is used, which is robotic process automation. And the typical outcome is that it creates more exceptions than anyone can handle. RPA has its own pros, but it also has its own cons. So uh, over the last 5 years, we're seeing AI or artificial intelligence, which is powered by machine learning and other technologies, surge into the enterprise, where AI plays a crucial game is where there is high volumes and there's non-standard processes. So with high variability, which essentially requires a lot of human judgment and human touch. Typical areas where AI is used as form automation, invoice processing, image identification, document digitization, approval process. Wherever there is human judgment, AI can augment the human predominantly. So what is hyperautomation? A combination of RPA and AI. So a combination of what I call as intelligent orchestration combined with really intelligence, which is artificial and which can be trained and which can be controlled with a lot of security, a lot of governance, and which is ethically correct. That is hyperautomation at the end of the day. Why is hyperautomation being talked about? Because of every organization wants efficiency. Every organization wants uplift in the experience, user experience, internal user experience, and external user experience, and then finally, ultimately, it's all about the money, where they can save money, where they can optimize costs, and save potential costs. That's where everybody's doing. So this is hyper automation. Let's now look at how AI is propelling this, right? I'm not going to spend too much time on this, but AI is everywhere, from Earth to Mars, right? On Earth, we have been hearing about AI being used for climate change, AI being used for protecting species, AI being used for early detection, curing of diseases, creating jobs, saving lives, etc. I don't know if you've all heard, but AI was used to identify new craters on the moon. And I don't know how many of you know that the Mars rover, which is currently on Mars, kind of takes 12 minutes before the signal reaches Earth, right? So predominantly the whole driving is done by AI. So AI is actually a driver for the rover on the Mars, if I can say that. So it's here to stay. It will stay here for a long time. Artificial intelligence and then the technologies around it. I'm a firm believer that when the movies start saying that AI will be real, it will be real. This is a good stat which I thought I'll put it there. 1927 to 2021, there are about 135 movies made where AI is either the main protagonist or essentially an essential part of the movie. So if those movies say that it will become real, it will become real. Let's see how time travel goes, though. It's still challenging, but then there's quite a bit of movies which have um, which have always spoken about AI, so must be true. On a day-to-day basis, we all know, but we are all using it, we are all trusting it, we are improving it, be it your Siris and Google Homes of the world, be it driving in a Tesla in a driverless mode, an auto-assisted mode versus sitting in a plane when it is actually flying on autopilot versus drones and stuff like that. So we all today are using AI, whether we want or not. We are trusting it. I keep taking the simplest example that how many of us trust Google Maps? Everybody does, right? And Google Maps doesn't ask us to drive off a cliff or get into the sea and stuff like that. So um, we are trusting it, we are improving it, we are on a day-to-day basis, the amount of data which is generated, we are using it, and we are helping it to improve from an AI perspective. Just some few stats just for all of us to decide whether it's hype or reality. It's a $191 billion market, the AI market. The funding generated in US alone was 37 billion in 2019. So you can imagine it would have probably doubled by now. Netflix recommendation engine is worth 1 billion per annum. There's about 300,000 patents for AI in the US. Using AI, supply chain management companies, SCM companies or organizations drove 44% cost optimization. This is a very interesting stat. 300 billion emails in a day around the world, and 50% is detected as spam by AI, which makes everybody's life easier. Workforce requirements by 2025, 80 million skills required. So again, for us to decide whether it's hype or reality, it's tending towards more reality than hype. It is inevitable. Everybody are talking about it. Every CIO, every CXO, every CDO is using it. Everybody's talking about it. But the most important stat, which I believe it's quite interesting, is by 2025, apparently, that the average person will have more conversations with a bot rather than a spouse. I don't know if that's good or bad for you to decide, but let's move on. Very quickly, there's a lot of misnomer on AI saying, AI, ML, it's the same, etc., etc. So let's be clear about it. 3 types of AI. We are just in the initial stage, which is the artificial narrow intelligence. We have not even hit artificial general intelligence, and that's a very firm belief from my side. Then the ultimate, which is at this stage a fiction or on paper, but a lot of work is being done, is artificial superintelligence. So narrow intelligence, general intelligence, and superintelligence. Narrow intelligence is more towards machine learning. It's called weak AI otherwise. General intelligence is more toward machine intelligence, or what we call as conscious computing at some point in time. It's more around strong AI. And then artificial superintelligence is where AI can kind of literally mimic the human being, including human senses. That's still in the works. Time will tell whether it will really come up or not. But I take this example of spices in a box. AI has multiple facets. So, but if you were to consider the top 5 spices in AI, for you to cook a dish with AI, you should consider natural language processing, machine learning, deep learning, computer vision, cognitive computing, and reasoning and explainability. You all know about this, but just a different way of using these spices and cooking a dish, which is with AI, which you can do with Azure, and we'll talk about it a little. With machine learning as such, 3 types: supervised, unsupervised, and reinforcement. But very interesting is about why ML is used, and more than often people confuse ML to be something very confusing. But from a learning perspective, if you can look at the applications to the right, where if you look at a picture and then identify if they're human faces, predominantly used for photo tagging. While processing a loan application, determine whether somebody will repay the loan, used for loan approvals, like that. Web advertisements, audio clips, translation, sensors. Sensors are playing a big thing, especially with edge computing, IoT. The whole point about machine learning is if you start training it about will it fail, and use that for preventive maintenance, and that's what will help everybody. So this is a quick view of ML. We're all seeing this. I'm just trying to basically demystify some of these common misnomers which people have, saying everything's the same, it's just a machine. No, it's not. A lot of companies have struggled to start with AI. Where do you start? What to do? Corporate functions typically are common places where you can start. IT has often given the maximum savings when you do AI or hyperautomation. Finance and accounting, a lot of people using it for finance and accounting, customer service, human resources, procurement, tax compliance, sales, marketing, you name it. And to the right here, there's a very, very interesting trend change in AI. Look, previously it was all all used for cost savings, but now it is driving growth, driving revenue, and improving literally top line and bottom line both. So it's now changing the face of the game by not only just doing back office, but it's coming into the front office as well, or improvising the mid office, or rather collapsing the difference or the gap between the front and the back office. What will be the challenge for us in the next 10 years from an AI perspective? It's ethical AI, explainable AI, and unbiased AI. You will hear this over the next 10 years a lot. Believe me, we will all hear about it, and we will all contribute towards AI being more ethical. We will contribute about AI being unbiased. Not to say that AI is not biased today. There are some data sets which are already been uploaded to AI which has some intrinsic biases, because the data engineers who uploaded them inadvertently had some bias coded into the data sets, but then it's all our responsibility to remove those biases from AI. A lot of people will contribute towards explainable AI, especially platforms like Azure or AWS as such. They will go all out in making AI more explainable and ethical and unbiased. Let's come to the ground level. We have looked at Moon, Mars. We've looked at the planes. Let's now hit ground level and look at how Azure is leading and helping. A lot of companies out there are using Azure for a comprehensive AI platform. So are we. We are called Provenio AI. We're based in Sydney, here in Australia. We have created a comprehensive AI platform, which essentially, when we go to a customer, what will a customer ask for when he invests in an AI platform? He will look at having absolutely less risk, low costs, secure and compliant, should be agnostic, should be scalable, and it should have insights and control. These are the key dials which you will get from Azure. And I think using Azure for a typical AI platform, I think is a brilliant idea. So let's look at it in terms of what people are using Azure for, and we'll take one of them and I'll show you how we have done it and the architecture behind it. Look, very interesting use cases. Trading platforms use AI for, I've seen Azure used in onboarding of sellers, onboarding of partners, KYC, if you've heard of it, vendor verification, those kind of processes. food retailers and delivery organizations have used it for demand forecasting, estimation, efficiency planning, etc. Tourism has used for personalized services. Video, online gaming have definitely used it for NPCs. My son's a big gamer. I wish I was a gamer, but those experiences with non-playing characters when they are really lifelike, and they are all based on AI, right? I mean, nobody can code so much. So console-like experiences across all device types is what AI is helping, especially in the video and gaming fraternity. Like that, nonprofit raising funds, disability, using it for education, employment, community services. Media services are using it for media plan booking and authority, which essentially is a very, very important and big process. All the advertisements which you see, all the booking, how does it exactly get programmed very methodically? I don't even have to mention healthcare. Healthcare is using AI big time, but then aged care is also using AI big time, detecting falls, facial recognition. Real estate is using it for contract and lease automation so that there's no people attending to it. Law firms are using it for contract management. And last but not the least, freight and logistics use it for invoice reconciliation process automation. During COVID, freight and logistics is still under extreme, I would call it under the pump. They are pressurized on delivering parcels on time. They're stretched. They're extremely under the pressure. So let's look at how AI is helping freight and logistics to automate a particular process. Intelligent freight reconciliation, driven completely by Azure. And this is what I'll be showing you and then talking about it right now. It's a 100 billion industry in the, it's expected to grow 4.5%. You receive parcels on a day-to-day basis. You order from, especially during COVID, all we did is sit and order stuff and waited for the freight and logistics companies to deliver it to us on our doorsteps. If just imagine if that had been shut down, right? So what typically happened during the COVID time is the freight and logistics companies had extreme pressure. There was absolutely no manpower, so they had to resort to technologies for them to be able to deliver properly. So taking one specific example of freight reconciliation, whether it is road freight or air freight or land freight or by water or by air, all of them uses complex invoicing processes. Now, one party to another party has multiple complex procedures when it comes to invoicing. So a simple invoice, it's not that, so if I use a particular courier service or a carrier service to take a pallet and deliver it somewhere, it's not just an agreed rate. There is a rate card, there is something called as demerit charges, there is fuel levy charges, which are specific to that particular time frame. There are cross-docking charges if you're coming from sea and then docking and then taking it by road. So there are multiple calculations into an invoice. And when somebody gets an invoice, they ultimately just don't check anything and then they just pay. So there are about 7 or 8 calculations within a particular value, and nobody checks that. And thereby, what they end up doing is ultimately end up paying at least 15 to 20% more than what they ideally should pay. So here comes AI as to how they can save that 15 to 20% and not overpay. So what typically we have done essentially is used Azure to automate the end-to-end invoice reconciliation process, and you'll see here in a moment as to how that works. And I'll come back to the architecture in a moment. Here's the complete backend here is Azure. Now, what you could typically do is upload your invoices. You can retrieve your invoices from emails, and this is where we've used a lot of Power Apps or Power Automate. The last one is essentially reconciliation. So some of these are typical analytics and insights which you can typically see on a day-to-day basis. But let us now just go into what this really does. So what it is basically telling you is whether it has read all the invoices, has it escalated any, has it rejected any, has it validated, and how many require permission. So let's go into require permission and see what it has done. So if you look at the whole system here, this is a particular invoice. So if you see an invoice in freight typically can go to a minimum of 25 to 30 pages. So it has got multiple pages in it. So what the system has now done is it's used Azure form recognition and custom form recognition to read all these invoices line by line, word by word, extract, and you can see some of the how unstructured these invoices are. Some of them have lines, some of them have tables, but some of them don't really have anything. So what they do is essentially come here and it literally rips through the invoice line by line. This is form recognition and custom form recognition in Azure. It extracts everything, and what it gives you is whether it has, whether everything is tallying or not, and is it lesser than expected or greater than expected. So what we have done is basically you can go to a line item. So if you see one line item, if you consider, you can go to that line item now and say, okay, I read everything and I say, oh, this needs permission. And then I see why. Why does it need permission? Because it says that the fuel levy on that day was something else, but it has considered something else, and hence it's lesser than expected. So there's an error there, and you're either overpaying or underpaying, and then if you're underpaying at some point in time, you will have to accrue, and your accrual is always at least 20% higher. So it has now calculated it, and it has included human in the loop to say, hey, look, there's a problem. Can you either escalate this, reject this, export this, or fix and approve? So if you fix and approve, it would approve it. Now, what you could do, escalate, write simple Azure functions to say, you can either email it or create a workflow, and I'll come to that a little bit. What we have also done is use the API ecosystem in Azure to integrate with other applications. Now, this is an ERP. This actually is from an SAP, like a similar ERP like SAP. Now it has gone to the ERP and brought back other details of that particular shipment, and you can actually validate that right here rather than going into multiple systems as such. So while ultimately what typically is doing is just imagine an invoice being processed by a human being. What the human being traditionally does is looks through each one of these and then actually enters it into the system. Some of them who are advanced will essentially use OCR, but the OCR failure rate is much higher than anything else here, because you just extracting will not do the job. You still have to calculate a lot. Now, imagine a system like this powered by Azure to look at every single invoice and then come back and tell us whether it is correct or wrong. In fact, you can write these in simple ways that nobody doesn't even need to go inside. In the front end, it'll kind of tell you whether the invoice does it match the PO? Is it the goods receipted? Is the PO's value correct? And then here, okay, I see that there's one problem. I go and reconcile and I say, okay, what's the problem here? It has extracted multiple things, but there seems to be a big issue. And what's that issue? It's the PO has been approved, but it is the goods have not been receipted. The GR is a common process within accounts payable, so it's not receipted the goods, and hence it has said that there is a problem, and then I have to look at it. Right. So I don't really have to now look at everything else, which is I used to do on a day-to-day basis. All of these are green. I only have to look at the reds, right? Now, I think you've got a sense of what this is all about. Let me just tell you the importance of this in terms of how this works in the regular sense. Now, what this is doing is this. So it has to retrieve invoices and completely driven by Azure. First is retrieval, getting invoices from either mailboxes or it could be from a SharePoint folder or OneDrive folder. Mailboxes can be tricky, but because anyone can send an email with something which has other attachments in it. So it has to really get into the invoice, understand the invoice, and extract only invoices rather than and junk other files. So there is extraction, or what we call as retrieval. There is the next aspect is classification. And what we have done is used custom vision image classifiers from Azure, which can basically classify the invoice based on where it is coming from. Is it Chinese, Japanese? Is it Australian? Is it land? It's sea? It's road, train? I mean, you can do multiple amounts of classification, right? And then classification models. The good part is classification models you can build within Azure. You don't have to go outside and write your own Python code or use any open source for doing classification algorithms. The third part is invoice extraction. So just imagine ripping through all those lines. You will need form recognizer. I'm sure you all know that form recognizer, for people who have used it, it understands US formats, but simple formats, which are one pager. So custom form recognition is the important thing, because it not only has to deal with so many variations of data, but it also has to understand each and every aspect of differences in it. So if you have already trained an invoice and next month it comes up with something else, then it should understand whether it should highlight that as an exception to the human, or it should deal with it with some business rules. So it's very complex in terms of the number of lines and the data it processes. So extraction is the most critical component. Traditionally, all of these have been done through OCR, maybe an Abbey, or for fans, for people who love Google and AWS, there are multiple things out there which can essentially extract stuff. AWS Extract has been nowadays doing a decent job, but comparatively from an Azure form recognition perspective, the number of formats and the number of variations it can handle is probably maximum. So I think if you're looking at extracting complex data from documents, Azure's the answer for you. Not only does extraction, but it has to translate, right? We process Chinese invoices, we process Japanese invoices, we process Korean invoices. Japanese and Korean are predominantly very tough to translate if you've done translation. But that's why you may, from a translation perspective, you may not want to completely depend on Azure. You will obviously have to go out to get some help from Google or any third-party translators. But depending, our experience with Azure has been so far good with translation. But again, you will really need to work on how much you're translating and how fast you need to translate. That's very important. Last but not the least, the next step is validation and balancing, which essentially is the next critical aspect after extraction. If you're extracting the right things, then you need to first calculate whether your taxes are correct, your additions, your arithmetic functions, or your algebraic functions, are they lining up? Is it making sense? Is the invoice balancing? Like, for example, is it charging $1,500 instead of $1,200? I'll tell you a simple example. Here in Australia, we did a small study and we understood that just by rounding off errors, people are losing hundreds of thousands of dollars. Just rounding off, even 2 cents over a period of time. If you have transactions of 40 or 50 million in a year, just imagine how much of money, and then that keeps doubling, tripling. I mean, you can imagine the amount of neglect which we all do on rounding off errors. So if a system can pick all of that and then at some point in time accrue, that's also great. So what we've done using multiple layers of serverless compute here in Azure, we have created basically everything revolving around AutoML. We've created data pipelines for it to start working with and ensure that the data which is offered or extracted is calculated, validated, balanced, and then the database aspects kick in. Once the validated and treated data is all done, it kicks off into the data factory and then the rest of the database components. Last but not the least, using Azure Functions, we have the human in the loop, which you saw, which was very intuitive to say, can I escalate, approve, or just reject? So it's very simple. Rather than going through every line by line, it's doing it automatically. Suggestion is obviously to have a good API integration layer to look at, tap into multiple APIs. So I'll just now cover from an Azure perspective what we did. How does it flow? It first retrieves all the invoices from wherever it is, mailboxes, websites, you name it. After it is retrieving it, we use Logic App to basically coordinate this whole function or orchestrate this function as such. Then it gets into the phase 2 wherein we're using custom vision image classification. Obviously goes into blob storage and uses Azure Functions to take it to the next step. The next step is all about form recognition, custom form recognition, using blob storage for temporary storage of essentially extracted values, and then using Azure Functions to again orchestrate it back into the validation layer. And in the validation layer, using Databricks, Databricks is predominantly for ETL tasks, post extraction essentially to look at where data should flow and how it has to be massaged at some point in time. AutoML for all aspects of calculation validation, the data factory for data sync, and then Cosmos DB for final treated data storage. You will need to store data because compliance aspects will ask you to store data for 7 years, 8 years, 10 years, blah, blah, blah. So that's critical. What we've also done from my company's perspective is we've created accelerators or pre-trained models. That means what we call as domain dictionaries, which essentially understands what an invoice is, what tax is. Because just think of it, right? India has GST, Australia has some other tax connotations, Japan has some other tax connotations. Every different currencies, the currencies differ, the definitions differ, the phrases differ, the acronyms differ. So you'll need a complex domain dictionary to kind of maintain all these translations. So what we've done is created a domain dictionary layer, also have accelerators which can already understand predominantly a lot of types of invoices, and all of them done and stored in Azure. And then finally uses Azure Functions to flag the exceptions to the current process, right? And essentially writing data to dummy or to pre-prod and then to prod. Just a double click on this so that you know what we're talking about. The data lake, which is the blob storage. Once we have done the orchestration process, it kind of has the containers for data preparation, processing. The Databricks access blob storage for data preparation and data processing. So both Databricks and blob storage plays crucial and critical role in the pre-processing stage of the invoice. Data preparation, harness the power of multiple, I would call it, but we've used Spark, and once the data preparation is done and the validation and the business rules are done, then you talk about the ML processing, which is running all insights. And this is where I think Azure ML pipeline or AutoML is critical and crucial. The amount of anomalies you can detect, the amount of exceptions you can actually detect. We just detected about 15 different anomalies for a company, and they ended up in a month they were paying one particular carrier $35,000 extra. So just by running duplicate, right? Duplicate checks. So these anomalies can save a lot. So all of the anomalies or insights or analytics, if I may say, is at this layer. And obviously the data migration part, once the process data is clean, then you can decide on what you can do. Power BI, obviously you can knock yourself out with Power BI in terms of how you want to configure once you have all of that data. And obviously with the data increasing, because you would process not less than 10 to 15 to 20,000 invoices a month. So just imagine the amount of data and the amount of intelligence which you'll get out of all that data. Then finally, using human in the loop as a very intuitive layer. So this is predominantly the architecture which we used, and then just the workflow which we used. So what we have now done, just to summarize it, we have taken about close to about 20 to 25,000 invoices a month, which is an average of at least 20 to 25 pages, with all complex layouts. You name the complications there in the invoice. We've used this whole Azure powered application which we have built, pushing all the invoices through that, extracting every single bit from the invoice, validating everything, and then telling the customer whether they can pay that amount or they should not pay that amount, and look at it and validate what's the error. And we are also basically telling what the error is. So what it did here in Australia, and now I'll come to the last part of my presentation. Hope I'm doing good on time. Looks like I am. Last part of the presentation, which is lessons learned in terms of look, my biggest point about using AI is when it really matters, right? I mean, during COVID, we all heard of stories where AI was used for samples, to prevent spreads, to ensure that communities are safe, etc., etc. But this is one simple example wherein it took us maybe 4 months to assemble all of these as key building blocks and assemble a solution. Now, in this solution, all freight and logistics companies had at least 10 or 15 people, manually validating these invoices on a line-to-line basis and approve. Now, those 10 or 15 people are redeployed to ensure that the parcels are shipped properly and then shipped faster, because they don't have to spend time on mundane activities like line by line reconciliation, and then asking people why this was wrong, and then get into that mess. The key lessons learned from our perspective: no, we didn't get this right. Step one, we had to do quite a bit of. It was not completely me; it was my team. But what we learned is it's very important to first focus on data pipelines. That's extremely critical. I think you all know how critical data pipeline is. That's where you will spend a lot of time. The second one is invoice training. Invoice training is, as you all, if you have all used form recognizer and custom form recognizer, it can get a little bit tricky. But the only thing I would say to people is have patience. It works. It definitely works. Once you've got a hang of how to train the invoice, whatever method you're using, it could be simple key value pair methods versus the complex methods of training tables and stuff like that. But it is critical for you to have patience. You will have to just play with the number of formats. People tend to hide behind the fact that, I don't have too many sample documents to train. No, you don't really need, right? I mean, advisably, you should have maybe 50 to 100 samples, but we've done certain invoices with 20 to 25 samples. So small data works in certain cases. You don't really need to have always big samples of data. Last but not the least, it's very critical for you to make it very intuitive. All of these AI projects fail because they're heavy, they're very intelligent, but they're not intuitive. The customer doesn't know what to do, or the client really is lost in terms of, okay, what do I do now, right? Okay, it's telling me something now. How do I use it? So make it extremely intuitive and simple to say. What the biggest lesson I have learned is all these AI systems should give you actionable intelligence. Otherwise, it's useless, right? If I get actionable intelligence because I'm busy doing 100 things, if it gives me actionable intelligence to say, do this first, do this next, and this should be done in the evening, that's it, right? So here in this particular scenario, it's telling you what to check, what to approve, what not to approve, and why not to approve it, and then what to escalate. So actionable intelligence is extremely key and critical, ladies and gentlemen. So just to summarize my whole presentation, I started with importance of I started with what is hyperautomation. We spoke about having AI and RPA combined together, but nowadays it's more of AI. We spoke about a little bit of AI. What are the methods? What's narrow versus general versus super AI. We then looked at some real-time examples of where AI is being used. And then we looked at one specific problem, which is invoice reconciliation within freight and logistics. And we looked at the application, which is completely powered by Azure. I have a team of people who are doing this. We're constantly improving more and more invoice formats, so much so that we're working with Microsoft now to see how we can upload some of the Asian formats into Form Recognizer, which I think will be a brilliant one. Right now, there's only US 1-page or 2-page simple formats. Just imagine if a Form Recognizer can easily process Japanese, Chinese, Australian, or even for that matter, Malay and Thai invoices and Indian invoices, right? So that's what we all hoping for. That's from me. I hope this was beneficial for you, and I could give you some light on how AI can be used in the whole automation to hyper automation journey. Take a pause here. Let me know if you have any questions. I'll do my best if I can answer them. Thanks, everybody, and have a great rest of the conference. Cheers. Bye-bye.
Techaholic was conceptualized in mid-2018 as an open community platform. Techaholic connects industry professionals, vertical experts, and learners together, bringing real-world relevance and career exposure for enhanced learning. Our vision is to enable professionals and organizations to achieve more through the community collaboration. Our mission is to nurture industry-ready professionals who can enhance nosiness outcomes with skills on upcoming technology landscape. And our values are to make everyone shine by sharing our knowledge, bringing honor to individuals, encouraging innovation by using the latest technology, networking to enhance collaboration, and encouraging excellence in technology-enabled solutions. We are creating communities with the motto of Go Far, Go Together. We empower individuals to achieve more through their skills without worrying about anything else. We help our community members to become industry-renowned, self-dependent professionals. To achieve industry recognitions, you can join our community to work with our existing industry-renowned community leaders. Our community leaders could mentor you and provide the stage to work with local and global communities. Mentors can lead you to the next level of growth. Techaholic empowers individuals to achieve their career aspirations by connecting them with the right mentors who are proven industry veterans and subject matter experts. Internships help you with real-world experience. Today's students are tomorrow's leaders, so we will not leave you alone. We have open internship programs to onboard technology enthusiastic students through formal process. Lead your digital transformation assisted by our industry veterans and technology community experts. Our designs are centered around business and technical requirements. We optimize your cloud designs to enhance administration and user experience. We secure your cloud with defense in depth. We provide guidance on cloud governance and compliance. Techaholic can also help you solve problems like lack of flexibility in capacity and cost optimizations, time to execute, efficient remote working, and infrastructure monitoring. Techaholic is making it easier for both freelancers and organizations by inventing a new way of working with freelancers globally. As a freelancer, you can choose your assignments either through your own network or through our network. We take care of all the onboarding tasks so that you only focus on your assignment. We are continuously growing our community to help individuals and organizations in capability building with skill-based learning. In the ever-changing job roles, we are extending the learning outreach by nurturing the future-ready and most desired professionals in the industry. We bring together a large array of technology professionals with varied industrial accreditations, eager to help build enterprise solutions and enable the learners. Now let's look at some of the popular industry certification courses offered by Techaholic. Techaholic was conceptualized in mid-2018 as an open community platform. Techaholic connects industry professionals, vertical experts, and learners together, bringing real-world relevance and career exposure for enhanced learning. Our vision is to enable professionals and organizations to achieve more through the community collaboration. Our mission is to nurture industry-ready professionals who can enhance nosiness outcomes with skills on upcoming technology landscape. And our values are to make everyone shine by sharing our knowledge, bringing honor to individuals, encouraging innovation by using the latest technology, networking to enhance collaboration, and encouraging excellence in technology-enabled solutions. We are creating communities with the motto of Go Far, Go Together. We empower individuals to achieve more through their skills without worrying about anything else. We help our community members to become industry-renowned, self-dependent professionals. To achieve industry recognitions, you can join our community to work with our existing industry-renowned community leaders. Our community leaders could mentor you and provide the stage to work with local and global communities. Mentors can lead you to the next level of growth. Techaholic empowers individuals to achieve their career aspirations by connecting them with the right mentors who are proven industry veterans and subject matter experts. Internships help you with real-world experience. Today's students are tomorrow's leaders, so we will not leave you alone. We have open internship programs to onboard technology enthusiastic students through formal process. Lead your digital transformation assisted by our industry veterans and technology community experts. Our designs are centered around business and technical requirements. We optimize your cloud designs to enhance administration and user experience. We secure your cloud with defense in depth. We provide guidance on cloud governance and compliance. Techaholic can also help you solve problems like lack of flexibility in capacity and cost optimizations, time to execute, efficient remote working, and infrastructure monitoring. Techaholic is making it easier for both freelancers and organizations by inventing a new way of working with freelancers globally. As a freelancer, you can choose your assignments either through your own network or through our network. We take care of all the onboarding tasks so that you only focus on your assignment. We are continuously growing our community to help individuals and organizations in capability building with skill-based learning. In the ever-changing job roles, we are extending the learning outreach by nurturing the future-ready and most desired professionals in the industry. We bring together a large array of technology professionals with varied industrial accreditations, eager to help build enterprise solutions and enable the learners. Now let's look at some of the popular industry certification courses offered by Techaholic. Techaholic was conceptualized in mid-2018 as an open community platform. Techaholic connects industry professionals, vertical experts, and learners together, bringing real-world relevance and career exposure for enhanced learning. Our vision is to enable professionals and organizations to achieve more through the community collaboration. Our mission is to nurture industry-ready professionals who can enhance nosiness outcomes with skills on upcoming technology landscape. And our values are to make everyone shine by sharing our knowledge, bringing honor to individuals, encouraging innovation by using the latest technology, networking to enhance collaboration, and encouraging excellence in technology-enabled solutions. We are creating communities with the motto of Go Far, Go Together. We empower individuals to achieve more through their skills without worrying about anything else. We help our community members to become industry-renowned, self-dependent professionals. To achieve industry recognitions, you can join our community to work with our existing industry-renowned community leaders. Our community leaders could mentor you and provide the stage to work with local and global communities. Mentors can lead you to the next level of growth. Techaholic empowers individuals to achieve their career aspirations by connecting them with the right mentors who are proven industry veterans and subject matter experts. Internships help you with real-world experience. Today's students are tomorrow's leaders, so we will not leave you alone. We have open internship programs to onboard technology enthusiastic students through formal process. Lead your digital transformation assisted by our industry veterans and technology community experts. Our designs are centered around business and technical requirements. We optimize your cloud designs to enhance administration and user experience. We secure your cloud with defense in depth. We provide guidance on cloud governance and compliance. Techaholic can also help you solve problems like lack of flexibility in capacity and cost optimizations, time to execute, efficient remote working, and infrastructure monitoring. Techaholic is making it easier for both freelancers and organizations by inventing a new way of working with freelancers globally. As a freelancer, you can choose your assignments either through your own network or through our network. We take care of all the onboarding tasks so that you only focus on your assignment. We are continuously growing our community to help individuals and organizations in capability building with skill-based learning. In the ever-changing job roles, we are extending the learning outreach by nurturing the future-ready and most desired professionals in the industry. We bring together a large array of technology professionals with varied industrial accreditations, eager to help build enterprise solutions and enable the learners. Now let's look at some of the popular industry certification courses offered by Techaholic. Techaholic was conceptualized in mid-2018 as an open community platform. Techaholic connects industry professionals, vertical experts, and learners together, bringing real-world relevance and career exposure for enhanced learning. Our vision is to enable professionals and organizations to achieve more through the community collaboration. Our mission is to nurture industry-ready professionals who can enhance nosiness outcomes with skills on upcoming technology landscape. And our values are to make everyone shine by sharing our knowledge, bringing honor to individuals, encouraging innovation by using the latest technology, networking to enhance collaboration, and encouraging excellence in technology-enabled solutions. We are creating communities with the motto of Go Far, Go Together. We empower individuals to achieve more through their skills without worrying about anything else. We help our community members to become industry-renowned, self-dependent professionals. To achieve industry recognitions, you can join our community to work with our existing industry-renowned community leaders. Our community leaders could mentor you and provide the stage to work with local and global communities. Mentors can lead you to the next level of growth. Techaholic empowers individuals to achieve their career aspirations by connecting them with the right mentors who are proven industry veterans and subject matter experts. Internships help you with real-world experience. Today's students are tomorrow's leaders, so we will not leave you alone. We have open internship programs to onboard technology enthusiastic students through formal process. Lead your digital transformation assisted by our industry veterans and technology community experts. Our designs are centered around business and technical requirements. We optimize your cloud designs to enhance administration and user experience. We secure your cloud with defense in depth. We provide guidance on cloud governance and compliance. Techaholic can also help you solve problems like lack of flexibility in capacity and cost optimizations, time to execute, efficient remote working, and infrastructure monitoring. Techaholic is making it easier for both freelancers and organizations by inventing a new way of working with freelancers globally. As a freelancer, you can choose your assignments either through your own network or through our network. We take care of all the onboarding tasks so that you only focus on your assignment. We are continuously growing our community to help individuals and organizations in capability building with skill-based learning. In the ever-changing job roles, we are extending the learning outreach by nurturing the future-ready and most desired professionals in the industry. We bring together a large array of technology professionals with varied industrial accreditations, eager to help build enterprise solutions and enable the learners. Now let's look at some of the popular industry certification courses offered by Techaholic.
Hello, and welcome to the session. I'd like to thank you very much for joining me this morning, afternoon, or evening, wherever you are. It's actually pretty early in the morning where I am. So hopefully, you have some type of beverage. Maybe it's a little bit later, but I have my coffee, and we'll get through this demonstrations and presentation here. As we move along, getting a little bit used to this interface here. I'd like to send out a thank you to the sponsors for supporting this, and also Techaholic for allowing me to present. I really appreciate that, and I hope you enjoy this session. This is me, Mike Nelson, and I will be talking about the practical and some unpractical uses for the WSL, the Windows subsystem for Linux. You can reach me at Mike Nelson IO on Twitter. Now Media is my LinkedIn, and Mike Nelson -IO is my GitHub, where you're going to find a lot of the things that I'm using today, like scripts and the actual links and what I'm doing in here in the demonstrations. So you check out Mike Nelson -IO and GitHub and under the presentations, and you'll see it there. Okay, so just a little bit about me. If you haven't met me before, I probably haven't met a lot of you before. It's kind of weird, It's not being in person and being able to look at people in the audience. I'm looking at a screen and looking at a light and not looking at people. And it's after a year, you'd think I'd be used to it, but still trying to get a grasp on it. I've got 35 plus years in tech, a lot of years experience across the board. I'm really a scripter, not a coder, so I couldn't code my way out of a wet paper bag, really. But I could script my way out of it, probably. I have a real passion for the community, for teaching, for learning, mentoring, along those lines. And that leads me into the some of the industry awards that I've won, the Microsoft MVP, Be Able to Be Expert, Citrix, so on and so forth. I live in the Midwest, USA, so I'm in the Central Time Zone, and this is my family off to the right there. And three of my favorite things, besides my family, is beer, barbecue. I love barbecuing and smoking meat and things like that. And then EVs. I started having a real passion when I bought my first Tesla. So electric vehicles are kind of my thing now, and I really like exploring them. And for those of that use WSL or use PowerShell specifically, they even have a Tesla PowerShell module out there, and you can do all kinds of crazy things with it. So it's really kind of cool. Next evolution of a gadget, I guess. So moving on. And I apologize for moving screens here with my head, so don't get too freaked out, because I've got multiple monitors, but I'm also trying to navigate this interface a little bit. I'm not used to it. So we'll be doing a little, I'm not going to go too deep into it, but we have to cover a baseline of WSL. For most of you probably know it, but we've really got to, go over it a little bit just to make sure everybody's on the same level playing field. Practical and unpractical, we'll step through some of those, and then I've got some demos. So now I'm going to show this video. Let me see if I can start this here. I know you can't hear the audio. You don't need to hear the audio, but this is a video that was done back in the 1980s. And it actually showed the Windows versus Linux and how that battle came about, because if you look at what's flying there, there's Clippy. Remember Clippy? But that butterfly was actually part of, if you remember, Vista. Linux was trying to go for the knockout there and everything. But I just wanted to show this because it kind of goes with what I'm going to outline here next. And get rid of this. I hate how they show those screens. Anyways, so free software licenses are the devil's work. This is what Microsoft PR came out with it in 2001. This is kind of scary, but now they've totally shipped gears on this, right? Steve Ballmer, Steve was, a crazy guy, but he said Linux, this is when he called it a cancer. And that's when a lot of people went after him and took offense to it and everything. But it's just, his idea of how Linux was around the same time. He got the whole Microsoft company thinking this way and kind of made it a mandate, which, wasn't really good, but that's what they were thinking. They were paranoid. And then finally, Linus, who created Linux, actually came out after that and said, make jokes about Microsoft, but he thinks the hatred is a disease. It really was. It was a disease that was populated through Microsoft. But as we all know now, Microsoft loves Linux. That's everything's cool. We love it. We even developed our own kernel that integrates it. So we love it. We were, forget about the past. A little comical going back in time there. So the WSL v1. This is the architecture. You've probably seen this. It's really, you got the kernel, you have the WSL layer, and you have Linux distribution. Now, the WSL layer was an actual full virtual machine. It was, you had to have Hyper-V running, and it launched a virtual machine instance, and that's how you got, the distributions to run inside of WSL v1. It was a great start. It really was. But it had a lot of problems. It introduced in 2016. It only had Ubuntu. Conical was really, pushing the integration with Microsoft. In 2017, a year later, they came out with the store images, and now you can actually do Win 10 version 1607 and Server 2019. You can add the WSL v1 to those. It uses a compatible kernel with GNU. So if you're from the Linux world, it uses a compatible kernel. It's not a full kernel, but it was a Linux compatible kernel. It could not scale. There was no scalability in the original WSL v1. There really isn't even today. That's why they came out with WSL v2. And it's not like, Kygwin. If you ever use Kygwin, some people pronounce it Cygwin, however you pronounce it. If you've ever used it, it's not like that. It's not like emulating an environment. That's not what the WSL is. And the no systemd, right? So if you don't know what systemd allows processes to run as what they call PID1. Okay, so a process identifier 1. It allows it to actually execute at the root level, at the kernel level. And there are things like Docker. So Docker really wants to run at PID1. And there's no way to do that in WSL v1. The binaries that required that type of interaction with the kernel, just that it wouldn't allow it, because there was no systemd. That's a big limitation. WSL v2 doesn't allow it either. I mean, they don't have it natively. There is an actual way to install it, which I'll show in the demo. So WSL v2 comes to play here, and we have the architecture a little bit different. You have the hypervisor. You have the kernel sitting on top now. Okay, so you have the kernel. Funny how they call it still the Windows NT kernel. Thought they'd get away from that, but then it actually goes into user mode. So there's a user mode and there's a kernel mode, and Windows has adjusted its kernel, if you will, since Server 2019, Server 2022 now, and Windows 10, that they've actually merged the kernels together. So the base core kernel is the same across those operating systems. And they now have split user mode and kernel mode. So then you have the Linux kernel, which runs in the hypervisor, right? And then it has a lightweight utility VM. It actually is just a real lightweight VM. It runs It does require Hyper-V, right? But it's much smaller footprint, and you really can't do anything with it. You can't even see it unless you run a specific command, which I'll show you. So it's no longer emulating calls. That was pretty prevalent in WSL v1. It uses a type 1, so it is a type 1 lightweight hypervisor, running just a single VM with an ext4 virtual hard drive. And it's called the system VHD, which you can find inside of the WSL directory. It's one kernel running multiple distros. This is kind of key to the premise of the architecture around, WSL v2. It allows just a single kernel, okay, to run multiple operating systems, distros, if you will, not operating systems, but distributions. And that means that there's not a lot of switching that goes on. There's not a lot of user mode or kernel mode or any type of logic switching that has to happen in order for those distributions to all run together. It's very quick. It's very efficient. And as if you've ever installed WSL v2 and you've installed one of the distributions, you'll notice you're up and running within seconds. Independent IPs. This comes into, not only the practical side of it, but also the unpractical, right? So you never could do independent IPs. You had to always stick with what they gave you. Now you can have each individual distribution can have independent IPs. And that really kind of opens a door for a lot of things, right? You think about it, it allows more flexibility. It's like containers. It's like, having K8s, Kubernetes, to be able to have independent IPs inside of the containers, which is possible. But in WSL v2, that allows the distributions to actually be independent as well. Even though they're running inside the same kernel, they can be independent. Docker created a new backend just for WSL, and I got a little bit behind that in a second. The host file system uses a 9P protocol. It's a protocol developed by Bell Labs. You may have heard of it if you've worked in the Unix world at all. I was actually raised on Unix way back when. That's how I got my start. But 9P protocol was, something that pretty much every Unix administrator knew about. Everything is a file. Okay, so that's what it's all about. Everything is a file, just like in Linux, Unix, the same thing. Everything is a file. And the IFS network redirector, this was created to actually allow for the bringing together the possibility of having opening up Explorer and being able to go to the Linux file system from Windows. That's actually allowed through the IFS network redirector. It allows that interoperability between the two. So a lot of moving parts, if you think about it in WSL v2, it leaps and bounds over what WSL v1 was. Now comes WSL-G. For those of you who don't know, WSL-G, if you have Insider's Preview build 21.21364, or higher, you can use WSL-G. Now, WSL-G is part of WSL v2. Actually, what it is it allows for graphics. It allows for being able to run X apps. And if you're not familiar with that, if you've always been in a Windows world, you don't know what X apps are, well, think of it as just Windows on Linux. That's what it is. Unix first came to play back in the 50s and 60s. 1950s, 1960s. It was, it uses something called Xserve, and Xserve, there's different names for it, different flavors, if you will, but basically allowed you to run a windowed application on top of Linux, which is, natively just a CLI operating system. When you bring up a Linux operating system, it usually just goes right into a CLI. Now you can get desktop versions and things like that go right into the GUI, but there's always a CLI that underlies it. Just like Windows, when you think about it, Windows always has a command processor. There's always something underneath it. Linux started out as a command processor. And the X Windows uses something called the Wayland, and it's the X Wayland X server. And this is something that Microsoft has really kind of pushed with something called Weston. And, you know, those two together, they've really kind of redone the way things happen with the X server world with the graphics. Add on to that the Pulse audio server to allow for stereo audio to go through, and free RDP, allowing for RDP into this X session. This is kind of big, right? This is something that people have been asking for. They've been developing hacks to get at, but this is really kind of a big deal. And being able to run a Windows operating, we have a Windows operating system and then run a Linux Windows operating system at the same time, not command line, but Windows, and then run Linux windowed apps, which also comes under the purview of practical and also maybe a little unpractical. I'll show one in a demo, but you know, it combines the best of both worlds. So it's a next step. And it's really a great thing. It has, you know, a lot of possibilities. So just real quick, the feature comparison, you know, there's not much to say here, except obviously the bottom one here is the biggest one, right? That's really the differentiator here. Besides the virtual machine aspect of it, the full Linux kernel, and full system call capability, which, you know, you get into when you use specific apps or you do specific type of coding, but performance across OS file systems. So if you still need that performance to go from Linux to Windows or from Windows back to Linux, in your app, if you develop applications or you have processes or scripts or what have you that you know moves data between them, you know, that copies files, that you know, generates I/O between them, you still want to be using WSL v1 because it's much more efficient than WSL v2. And I have a test I'll show you what the difference is. But just keep that in mind. Performance across OS file systems, WSL v1. Okay. Then Docker. So I talked about Docker. Docker now has that backend they created. When you actually install Docker Desktop, it comes up and says, hey, you've got WSL v2 instead of Hyper-V, which was WSL v1. And do you want to enable it? And what that does is that gives Docker the ability to embed itself into the distributions that you have. So if you are a developer and you use Docker containers, or you know, you just have a need to use different types of containers within Docker, even from the Docker Desktop aspect of implementing Kubernetes, then you want to enable this, because then you'd be able to cross-platform access those containers and be able to run them between them. It's really seamless. I mean, you can run a Docker container right from a WSL session, that even though it's running on your Docker Desktop in Windows. So it's really seamless and it's really efficient. So they really did a good job on this. This is a line. I'm not going to spend a lot of time on this, but this is how it all, you know, works together with the Docker and everything. So let's look at some practical things for the WSL. It was raised on CLI. So if you have a familiarity, if you've worked in Unix, if that's what you were born into, it's pretty much muscle memory. Okay, so from the CLI perspective, not the WSLG, not the graphics of the Windows, but from the CLI. So, you know, if you know that, it's a familiar thing. You know, it's something that you really could get some practical use out of. If you work with appliances, okay, so something that IDC came out with is that there's something like 98% of all appliances, plug-in appliances that go in, that serve an application or provide a service, run on Linux. Okay, even Microsoft came out and said that Azure, I mean, in Azure, over 65% of the virtual machines that run in Azure are Linux. They're not even Windows, they're Linux. So Linux is a very sleek, very lean, very fast, and very process friendly operating system. So less than 2% of 300 million users run Linux, though, from a desktop perspective. So it seems like what you have is like a lot of the back end is run on Linux, but a lot of the front end is run on Windows. Okay. Which, kind of makes sense because you get a nice, pretty front end, which you could get from Linux, but it's not as, not as common that like Microsoft Windows is. But, on the back end, who really cares what's running on the back end, right? But for because you're a system admin, you have to know that. So it's very practical that you understand the WSL and how to work with appliances and how you can interact with them. Cross-platform Docker containers and Kubernetes. I talked about that with the K8s and K3s. Cross-platform development, PowerShell, React Native, Ionic, HTML, JavaScript, CSS, all of those. I mean, if you do cross-platform development, if you have an app and you're told that it has to work on both Linux and Mac OS, which is Linux, right? It's Darwin, it's Linux, and also Windows. Really kind of cool that you can use a WSL and you'd be able to do that platform development. Flexible automation, administration, automation frameworks that cross over. And what I mean by that is a lot of folks use PowerShell for administration. Well, now PowerShell is cross-platform. So you can run it on Linux, you can run it in the WSL, you can run it on Windows, obviously. You can run it on Mac, you can even run it on ARM. But even other frameworks that allow for automation. Okay, so you might have a vendor that has the ability to run on multiple platforms. You could actually run it inside of the WSL rather than having to have a dedicated Linux box just to run that. You can run it inside. And it makes VMs optional. You really don't, if you want to spin up a VM, go ahead. If you have the environment, if you have the local resources or the data center resources to just spin up a VM and you want to maintain that, you want to, if it's in the cloud, you want to continue to pay for that, feel free, it's your choice. But at the same time, if you just need something that's local and you need to do specific things, or, you just need to get in and get out, WSL is probably, again, a little more practical. Okay, so when we talk about cross-platform development in VS Code, this is the same with like Visual Studio. A little bit different. VS Code actually launches a VS Code server in Linux. So I'll try and show that in one of my demos. But it basically allows for the interaction between the two through a port and through the volumes. So whenever you're working in VS Code in Windows, you can actually be also working at the same time in VS Code running in the Linux operating system. You see that? It allows for that at the same time type of cross-platform development or cross-platform interactivity, if you will. So let's look at some unpractical maybe, okay? Linux apps are better and cool, okay? So if you were raised on Unix and Linux, you probably agree with this. There's a lot of Linux apps out there that were created just because of a coolness factor, to be honest. They would go out and they would program some crazy stuff. And there's some that's actually better. You think of it, you pay a lot of money. I'll give you an example. You pay a lot of money for a 3D modeling application, okay, as an example. The one that does wireframes and like, professional Hollywood studios use. You pay a lot for that. But in the Linux world, you don't have to pay a lot, okay? You pay for the support, but the application is actually free, all right? And sometimes it's even better. There could be an argument made that one of the apps that I'll show you is called Blender, and there's There's a couple of them out there in the market. There's one called Maya, Blender. They're 3D modeling apps that are actually used in like Hollywood to generate graphics for Pixar movies and things like that. But they have actually proven to be better than what you can get on the Windows platform. And that's just because Linux handles the memory and the CPU and the rendering process, which is, phenomenal in how much processor time and memory and swap and all that other kind of stuff it takes up. But it's actually much more efficient, and it's just a better app. Hacking is native, it's supported, and it's encouraged. So if you've ever worked with Linux, a lot of the hacking, and I mean by hacking both, good hacking, a little bit of white hat and a little bit of black hat hacking is actually, native to Linux. I'll be showing the Kali distribution, which is really kind of a pen testing, defensive, and offensive, red team and blue team operating system. Distribution. I keep calling it operating system. They're really distributions. But it's really supported. It's encouraged. It's something that makes things better. It's a little bit different than the Windows world. The Windows world is very, very defensive, very hands-off, very, you just bring up the name of Wireshark and some Windows-only users get really kind of freaked out by that. The sandbox, throwaways, no paper trail. Windows did come out with a sandbox. I don't know if you're aware of that, but in Windows 10, you can actually enable the Windows sandbox and it brings up an environment to just throw away. But they never really had that before. In order to do a sandbox, you had to bring up a VM. You had to, that's the only way you could do it. Linux has always had that. And and now with the WSL, it's the same thing. You basically can bring something up, use it within seconds. I mean, within 30 seconds, I can be up and running inside of a Linux operating system doing something. And then 5 minutes later, I'm done with it. I just throw it away and I unregister it and it's gone. And there's no paper trail. There's nothing there because it gets deleted from the disk. And if you are using on the Windows side, being Windows, if you have encryption or BitLocker or anything like that on, there's no evidence there. So unpractical. Yeah. And create your AIO. If you're not familiar with what AIO is an all-in-one. And you can create your own. Go ahead and, create your own, distribution and throw whatever you want in there. And then you can distribute it. And it's kind of really cool to play with. You have time, everybody should take time and just play with stuff. It's my opinion. And it is really kind of cool to play with. So some key points to remember, and we're getting to the demos here in a second. Slashes, case, and carriage return line feed. These are all things to keep in mind because when you work in the Windows world, it comes, you don't even think about it. It's something that just comes to you. In the Linux world, these are very specific. Case sensitivity is really important in the Linux world. So when you're typing something that has a capital letter as the first letter in the name. If you don't make it capital, Linux will say, I don't know what that is. Same thing with carriage return line feed. Linux really just loves line feeds. They really don't like the carriage return line feed, which Windows gives, as you know. So I just ran into that problem where someone gave me a file to use, a configuration file. I put it in the WSL, into a distribution in the WSL, and it wouldn't run. It was a shell script. It wouldn't run. And sure enough, I'm looking in my Visual Studio Code, and right on the bottom there, you can switch between, the carriage return line feed and line feed. Just switch that, boom, script ran, no problem. Slashes too, // they're different. They're just the opposite between the operating systems. EXFAT, FAT32, NTFS, it's not the same in the Linux world, okay? So when you're talking about even geometry of the virtual disks, but also the permissions, ACLs, they are different and they do not transpose between the two, okay? So when you move a file from Windows to Linux, you have to be very specific. If you don't care what it is, it's automatically marked as read write, read read, for those in the Linux world, that just means that it's allowed, that user that did the copy is allowed to read and write to it. But you're going to have to do what they call a change mode, CHMOD in the Linux, just to change the mode of that file to match what you had in Windows. There is a utility, one or two utilities I think I saw on GitHub that do this for you automatically, but I haven't tried them. I don't know how well they work, or if they, if they even work. I'm not sure. A home is another dimension. $home. So we're used to in the Windows world being home, home path or home dir, and that puts us into our users, whatever. Home is just another dimension inside of Linux. It's actually home/user, right? But it's really important to understand that you want to be doing everything inside of the home, inside of your home. In Linux, unless you're doing things as root, which, in WSL, probably not a big deal, but with, great power comes great responsibility. And you usually don't want to be running root either way. But so just understand the differences between the home, folder in Windows and the home folder in, or actually location in Linux. Environment variables, it's not seamless, okay? So if you make an environment variable in Windows, don't expect it to work in Linux, and vice versa, unless you use this tool called WSL-env, which you can put a colon-separated list of environment variables in Windows, and it'll bring it over to Linux, right? Otherwise, you have to do that manual thing inside of your scripts or inside of your code that actually sets those variables between the two operating systems. These are some configuration files that you will probably really want to know about, especially when it comes to tweaking the WSL. In each WSL distro, you have an etc, or you create an etc WSL.conf. You also have on the Windows side your home path.wsl config, and then you have for WSLG, you have a new configuration file under the program data Microsoft WSL. The biggest one is on the Windows side, the WSL config, .wsl config. That one actually sets like memory and stuff, and I'll show you. I'll show you that. WSL update. It's actually WSL -- update. I'm not sure my two dashes went into one dash on the slide, but it's WSL -- update or via Windows Update Service. You want to run this every once in a while because, oddly enough, unless you have it set as updatable in your Windows updates, which is, what's the option? I think it's like check for other Microsoft program updates when you do updates. I don't remember the wording. But if you don't do that, you actually manually have to run WSL -- update. And what that does is that updates the WSL kernel. And sometimes they don't tell you that it's been updated. If you follow them on GitHub, then yes, you would be able to know that because they post all their revision changes on GitHub. But just keep that in mind. And you need to be using, insiders or the 21H1 build. And it's kind of important that you get up to that. So you're going to be on the beta channel or the developer channel in Windows, not just the normal release channel. All right, so we're going to get to some demos here. And I wanted to bring this gentleman up. You see, this is what I'm going to be doing. I'm going to be showing you a demo, two big screens. This is actually William English. He was the inventor of the computer mouse in 1963. He passed away in 2020. But if you can see, he's actually, he's a creator of the mouse. And I thought it was kind of cool to show it as a demo. So I'm going to check my time here, and if I can get over here to my screen. Okay, so I want to show this screen. Okay, I'm going to stop and I'm going to show this screen first before I flip over to my demonstration, just so I make sure that you see it and I don't run out of time like I did in the last one. This is a takeaway slide. So V1 and V2 is all about cross-platform I/O. That's the biggest difference. If you want to keep it in your head, yes, it's about the kernel. Yes, it's about the VM, but it's really about cross-platform I/O. V2 should be your default. When you implement a distribution inside of WSL, you can say, you can make it either version 1 or version 2, and all it is a conversion. It goes in and it converts the distribution. When you actually bring down the distribution and install it, you can also specify that. But WSL-G, the graphics side, it needs to mature. It is immature, and Microsoft acknowledges that. They're still working on it. They're still building on it. It's something they just introduced, so think of it as still beta. Docker is still kind of relevant. Now this is a point I wanted to make is Docker is kind of like trying to find some relevancy. Kubernetes really kind of stole the show, right? With containers. Docker is their push with bringing the Docker desktop and merging it with WSL. This is my opinion. I've shared with some other folks, but they're still trying to remain a little relevant on this. And this I think this is their attempt. Their success is unknown at this point, but Linux isn't so terrible, is it? So a lot of Windows users going way back to their 2020 and stuff, early 2000, 2001. Linux was terrible. Is it really that bad? It's really not. It actually is, kind of helpful, and it's really kind of helpful to use the two together. Beta and dev channels can break things. So, like I just said, you have to be running on the developer or the beta channels, the flights, as they call them, for Windows. The thing is, it can break things with WSL, and they're very well documented. But when you get that update and it breaks, you're like, oh man. So that's why I don't do updates to Windows Update Service, so it doesn't get automatically applied. I do the updates manually because once it, you have it set so it doesn't break, you don't want to update it, right? But those things will break. They right now I don't have Explorer functionality into the Linux file system because that is a known bug that they broke way back when, and they still haven't fixed. Apps can have the best of both worlds, cross-platform, right? Being able to work in both and be able to, have people have the same look and feel across operating systems for whatever they choose to use. And remember these slides. This is a slide I showed before. To remember those. Those are always things that you should remember working with WSL. And of course, open source code is awesome. Embrace open source. It is a great thing. And contribute, give your feedback. It's really important. Microsoft has realized this. If the last 5-10 years, they've really pushed towards open source. Now more than ever, it's just something that you need to embrace if you're going to continue on in this industry. Okay, enough of that. Let me get out of this. I'm still showing my screen. Awesome. And let me just make sure. Yep. I'm over here. Okay. So this is Windows Terminal. I don't know if you've used Windows Terminal before. I highly recommend you do if you haven't. But Windows Terminal, has come a long way, and it allows you to run the WSL. You can run the WSL native out of command line if you want. You can just open up a command line window and run WSL, right? So if you just run WSL from here, it's going to run your default distribution. Now I'm actually running in Linux. All right, so this is the Linux operating system, as you can see, not the Windows operating system. But you notice I'm reading from a Windows drive through Linux, which is kind of cool. All right. So, if you want to, just a couple basic things just to set the stage here. If you do a WSL list, I'm inside of it. I'm sorry. You do an exit to get out. And I do a list or just an L. It'll show you all your distributions that you have. Now, you'll notice some distributions here. Yeah, they come from the store. Some do not. And then there's some that are like the Docker desktop. That's all part of the Docker desktop. You shouldn't mess with those, because if you mess with those, your Docker desktop's not going to work anymore. But you'll notice some of them you can get in the Windows Store. If you haven't done that already, you just basically open up the Windows Store and search for WSL, and you can download and start up an instance. But it's really kind of important that you can do custom. And you'll see here I have like OpenSUSE Tumbleweed, and I have Arch Linux. Those aren't available in the store, okay? But you have the ability to bring those in. That's kind of like the custom thing, roll your own. There's a lot of things out there in the web that talk about how to actually bring in their custom distribution. So think about the practicality of this. Having a distribution that your company uses for a specific purpose, development-wise or sysadmin-wise, you can take that image, just a VHD file or VHDX file, and take that image, distribute it, and people can import it directly into WSL and start it up. They don't need a special configuration on their machine. They don't need anything like that because WSL compensates for all that. It just opens it up. Okay. I've had people that have created, I've had people that have created a custom distribution on a machine that was like so archaic and so slow. It was still running Windows 10, but they created the image and then they gave it to people that were running all kinds of different platforms, and they were able to import this image and run it seamlessly. There was no configuration changes, no nothing. So that's the beauty of being able to run these kernels together under a unified Windows kernel and be able to integrate the two. So from this aspect, I want to show you something, being able to show what is, just again, you do a -v here and it'll show you actually what is running and what's not. But notice the version number here. This is where you're going to want to set the 1 and 2. And you do that with a WSL command. If you just run WSL with the -, you can see all the commands. And one of them is called set version. This will allow you to change the version number. Okay. So there's a couple of creating, distributions. One that I use is actually called a utility from a gentleman named Patrick Wu, who works for Conical, but he created something called PSUWI. So if you use PowerShell, that's something you're going to want to use. I'll do the get command on it now just to show you. But it allows you to create obviously the, I spelled it right, get command. You create a new Ubuntu instance, remove it, all of them, remove Ubuntu. I've actually modified this. Okay, so I've modified it from Patrick's. I'll be posting it in my GitHub. I've expanded it to allow you to name things, and I'm also going to bring in like Debian instances so you can have multiples. But if you want to create multiple, images of the same operating system or the same distribution, you want to have a tool like this. Okay, you can't do that from the store. When you install from the store, it installs that particular distribution. You can't, when you reinstall it, you actually can't reinstall it over the original, or it'll overwrite the original. Now, keeping everything up to date. Hey, what if we want to do that cross-platform thing, right? So if I went through here and told it I want to keep everything up to date, I can tell it, hey, WSL Ubuntu 18.04, and go in as root and then run the apt update. Okay, so if I run this, it's actually going to go through and it's going to say, okay, I'm going to go through all these and run an app update for this particular version of Ubuntu. But what if I created my own script, which I did? So I just go through and I say, hey, update WSL distros, put a string on the end of it of distro name, and you can put a wildcard. So you put Ubuntu star, and it'll just, run through a for each loop, and it'll update all of them. So that's one of the biggest things, is keeping those Linux distributions up to date. It's kind of like running Windows Update. It's the same thing in Linux, but you want to be able to do that automagically. And you can actually put this as a scheduled task. So it goes through and updates every time you boot, or, every week, or whatever you want to do. But I'll have the script available in my GitHub. Running short on time as usual. There also is a PowerShell command available I want to show. And it's written by a gentleman named Stephen Groot. And I have his, where am I? Sven Groot. There he is right there. So there's a WSL management module. You'll notice it's kind of old, 2 years old, right? You updated it 9 months ago, but it's still incredibly relevant because it allows you to manage WSL within, PowerShell on the Windows side. So it's like, being able to, do a WSL git command. I don't even know if I have this loaded, but I see. Yeah. You can enter it, export, import, invoke, all that kind of stuff. The same things you can pretty much do from the WSL command line, but they've wrapped it into PowerShell. So if you use PowerShell, you want to do that. One of the tips I want to give you real quick is that clock skew. It's very important to understand if you're working between the two Windows and Linux, clock skew becomes a problem. And I've noticed that where the Linux clock will be a couple seconds, and then eventually if you run them, let them run for a long time, they'll start to go into a couple minutes off from what your Windows time is. And that's because it's using the kernel different hardware clock. It's an emulated hardware clock. So you actually need to run a command called hwclock -s inside of the Linux operating system to go out and get set the clock correctly to the Windows time. And you can run it as a script, right? So you just run it as a script to go through all of your distributions, just like you use the exact same script I have, just change the command to hwclock -s, right? And I'll put that out on the GitHub as well. So I want to run a real test here. I've only got like 3 or 4 minutes left here. And I apologize if there are any questions. You can always ping me. I'll give you my information. But I want to run a test here between these two. Now, what I've done here is I've got 2 different distributions. One is Demo Test V1, which is running as a WSL V1 and a Demo Test V2. They're both running Focal, which is a 20.04 version of Ubuntu, and both of them have the same updates, everything. But they're just native images. I haven't touched them, haven't added anything to them. That's where they are. So you could run a test like this that basically goes out and does a check on, how long does it actually take from a benchmark standpoint to, go out and do things with the CPU and the disk. Now with WSL V1, it doesn't have, you'll notice it doesn't have the individual disks as a block device, okay? But it does do a sequential read. What DD is an actual disk utility. And then if I do that in V2, the same command, you'll notice it does see the disk because WSL V2 recognizes the block devices. And if you look comparison between the two, once it's done here. So first run 14, second run 16, 18, and 16, right? Over here we have 678, 679, 710, and 689. Huge difference. Now what it's doing is it's doing that DD read between the Linux file system and the Windows file system. All right. That is, like I said before, the big thing about WSL V2 and V1. All right. If you want that performance, stick with V1. I mean, that makes this makes it incredibly obvious. Okay. If you take a look at just doing a regular DD, and this is V1, all I'm doing is saying, hey, go to my mount, my E drive. The E drive is mounted from the Windows platform. If I do that, it's going to go out and say, okay, I did that. This is the rate I did it at. I did it over here on demo 2, doing the same thing to a different file, same amount of data. Okay, so 2.33, 899 megabits a second, 0.58, 3.6 gigabit a second. Huge difference. So that just kind of proves that out right there. Okay. I've only got like 50 seconds left here. I've got a lot more things that I wanted to show, obviously. Spent too much on the slides. I apologize for that. But I will make my entire demo file the scripts, everything available in my GitHub under the presentations folder, under the PDC conference folder, and you can read it all there. You can try it out there. But if anybody has any questions for me, if I could switch back to the slides here once I figure out how to do that. And I need to change, swap the presenter view. All right, so reach out to me at Mike Nelson IO on Twitter. Mike at MikeNelson.io is my email address. Anything you want to talk about, WSL, any questions you have about the files that I have out there, the code, or anything in general, just let me know. Thank you very much. Have a great, wonderful morning, afternoon, and evening, and see you later.
Techoholic was conceptualized in mid-2018 as an open community platform. Techoholic connects industry professionals, vertical experts, and learners together, bringing real-world relevance and career exposure for enhanced learning. Our vision is to enable professionals and organizations to achieve more through the community collaboration. Our mission is to nurture industry-ready professionals who can enhance nosiness outcomes with skills on upcoming technology landscape. And our values are to make everyone shine by sharing our knowledge, bringing honor to individuals, encouraging innovation by using the latest technology, networking to enhance collaboration, and encouraging excellence in technology-enabled solutions. We are creating communities with the motto of Go Far, Go Together. We empower individuals to achieve more through their skills without worrying about anything else. We help our community members to become industry-renowned, self-dependent professionals. To achieve industry recognitions, you can join our community to work with our existing industry-renowned community leaders. Our community leaders could mentor you and provide the stage to work with local and the global communities. Mentors can lead you to the next level of growth. Techoholic empowers individuals to achieve their career aspirations by connecting them with the right mentors who are proven industry veterans and subject matter experts. Internships help you with real-world experience. Today's students are tomorrow's leaders, so we will not leave you alone. We have open internship programs to onboard technology enthusiastic students through formal process. Lead your digital transformation assisted by our industry veterans and technology community experts. Our designs are centered around business and technical requirements. We optimize your cloud designs to enhance administration and user experience. We secure your cloud with defense in depth. We provide guidance on cloud governance and compliance. Techoholic can also help you solve problems like lack of flexibility in capacity and cost optimizations, time to execute, efficient remote working, and infrastructure monitoring. Workaholic is making it easier for both freelancers and organizations by inventing a new way of working with freelancers globally. As a freelancer, you can choose your assignments either through your own network or through our network. We take care of all the onboarding tasks so that you only focus on your assignment. We are continuously growing our community to help individuals and organizations in capability building with skill-based learning. In the ever-changing job roles, we are extending the learning outreach by nurturing the future-ready and most desired professionals in the industry. We bring together a large array of technology professionals with varied industrial accreditations, eager to help build enterprise solutions and enable the learners. Now let's look at some of the popular industry certification courses offered by Techaholic.
Welcome, everyone. Just want to check the audio. Can you hear me? Thank you. Thank you very much. A very good evening, good morning, good afternoon, depending on wherever you are joining. Thank you very much for attending this 3-day session focusing on many different technologies. And I hope that you learned a lot from many of our greatest presenters throughout these 2 days. There are multiple tracks. And one of the good things about this is that you can always come back and watch it later because they're all live streamed in the YouTube. Now, I want to first thank our sponsor who basically made this event a successful one. And with this, I want to quickly talk about the agenda of this topic today. So it is Azure Serverless, and myself is Riju, and I work for Microsoft as a cloud solution architect. Here you have my Twitter and LinkedIn, so I keep posting resources in both the channels, so you can subscribe to those things and get to know about it, right? Now, what I'm going to talk about is all of them, not everything, definitely, because 1 hour is not enough to talk about all of this. What I wanted to showcase here in this one single slide is about the Azure serverless portfolio. Okay, so when you think about serverless, you think about not really deciding or focusing on the size or specification of the server. Either they are managed by you or somewhat managed by the cloud vendor. You don't really know what kind of server that is, right? You just need to say, I need to work on this kind of workload. Either it could be an integration kind of workload, or an application kind of workload, or a database kind of workload, or something like an app gateway kind of workload. I want to work in that workload, and I want to decide on my way of working, and I will let the cloud vendor decide on the resources it may need depending on the need or the kind of load coming into that. So that's what serverless is. So serverless doesn't really mean that there is no server. Yes, there is a server. There are servers. And those servers are not available in terms of you to decide and manage or maintain, or even you don't get to see those specifications at all, right? So they're hidden. They are basically behind the scene, helping you to host the kind of workload you want to host. So you can see over here, I try to capture most of the kind of buckets here, but each of them contains one or more services within Azure. So Azure comes up with a lot more services in terms of serverless database, in terms of serverless compute, so on and so forth, right? So this is the only slide I have, and I'm post with which I have a resources slide, which nothing but set up links. What I wanted to highlight over here is that this link, right? If you see this link, this is a learning challenge. So it's a custom made learning challenge, which I made for you guys. If you want to learn about serverless technology, so I picked a few of the Microsoft Learning and made it a learning challenge. And this learning challenge is available for next 73 days. And I have posted this link in my LinkedIn channel. So you can also go ahead and go through those learning exercises, and there'll be a live dashboard available. You can see how much progress you have made, etc. It's a great way to really focus on something rather than sharing everything which is available in documentation, right? Documentation is clearly large, right? So that's the only slide I have. So let me go back to the demo. Okay, before I jump into the demo, I wanted to first let you see the resources I have posted somewhere in a GitHub repository, and the link is on the first one. So if you go into that link, you will get all the links. So you don't have to copy all the links. Just go to the first link, and you'll be able to get all the resources over there, including the slide I'm using. So if you want to download the slide, which already has the link, go ahead and download the slide. So they are all available to you. So you can pretty much go ahead and get things from there. Okay. So with this, what I wanted to do is that I wanted to pick one service at a time and then explain over the actual Azure portal and talk through it. Okay. Right. So the first thing, you already have seen probably the function app, right? So I will not spend a lot of time talking about the function app because we had a dedicated talk on the function app, but I will show you, if the time permits, at the end of the session about function app. But other than function app, there are a couple of other things which you can think of as a serverless, right? So let's explore them. Let me go to my Azure portal. So I am right now in my Azure portal, and you can see that this is somewhere in the browser. So that's fantastic. And I go to this home page, and I can create a resource, right? So let's first start with a resource group. So let me create a resource group, and I'll put everything inside that resource group. So if I say that RG PDC 2021 and then B, that's the second one. And you can choose any region. That doesn't really matter. You can select other region for resources. So you do not need to get confined into one single region if you select something different. Okay. So you have this resource group created. It is right now available over here. And you can see that I have got this PDCB, which is sort of like an empty resource group at this point in time. There is no resource. Now let us first create a resource which looks like a serverless kind of thing. Now, first thing which comes into my mind about serverless technology is creating a workflow, because a lot of application today needs step-by-step things, sort of like a pipeline. You can think of like what you need to do one after another, right? So we can call it as a pipeline. We can call it as a workflow, right? So let's call it workflow. Now, if you think about workflow, right, it's very critical for any application because it's not just user-based interface, right? Always a lot of back-end work happens, and then they need to happen sometime sequentially, sometime in a disconnected mode, sometimes in a flow of mode, right? So let's go ahead and create something which is called logic apps. So if you create a logic app, now there are two ways by which you can search. One is top, one is bottom, right? Search and from anywhere. Doesn't really matter. If you get the right resource, that's all you need. I say go ahead and create a logic app. Now when you say that, I go ahead and create a logic app, after you select which subscription you want to select it, and the resource group you are right now in, that's B. Okay, that's the one which I created. You can even create a resource group on the fly during the resource creation. That's also very convenient. And then you choose this consumption-based model, right? Consumption-based model is the true serverless model because it doesn't really hold any resources for you when you are using it. Then only you will be able to, let's say, get the resources allocated for you, right? So you give a name. Let's say I give to it PDC LA. LA stands for Logic Apps. So I give this name as Twit PDC LA, and I can choose any region. So I can say Central US, whichever region I want to prep my Logic app to be. So do you need a log analytics? For the timing, I don't need. By the way, this is also sort of like a serverless, so you don't really specify anything. You go ahead and so analytics platform, which I shared in my first slide, is also serverless. Okay. So you could go ahead and say, go ahead and create. So it will validate whether I have all the rights to create this resource and everything, right? So all the authorization will happen at this point in time. Authentication definitely has happened, and then authorization will happen at this point in time to make sure that I have proper rights to create the resource. So I need specific setup contributor rights to this Azure subscription, which I already have. And then you can see that it will be ready almost immediately. And you can see that notification says, so you can click on go to resources, and it takes you to this designer. Because it is for the first time, right? You see all these options. Now, Logic Apps works in a trigger-based model, which means that when Logic App gets created, you basically can call it in many different ways. You can have an HTTP endpoint and just call it, right? That's a webhook. Or you do something outside of the Logic App. Maybe in a storage account, you put some file, and then Logic App kickstarts. Maybe you send an email to a specific mailbox. The Logic App can kickstart. Like that, there are many different triggers which can initiate the Logic App flow, right? So we call them as the trigger. And there are few commonly available triggers you can see available over here, which enables you to kickstart the Logic App. Now let's use something which is very common, like tweet, right? So somebody tweeting. There are a bunch of, let's say, billions of people tweet every day, right? So Twitter is sort of like a craziest thing today, right? So you see that Twitter connector is now available in my Logic App designer. So this is a designer, right? So what you see is the sort of like a user interface, right? But behind the scene, it's a JSON based configuration. So it's that JSON file which gets generated. You can even modify it from your Visual Studio Code. If you want to change something which is inside of the JSON, you can do that. So you can have more control, which is sort of like limited in Designer. But we'll use Designer to kind of like have less confusion. So let me just delete it. Okay. And I will go to this Logic App again. Let this designer come back. Okay. And then first, I need to authenticate myself with the Twitter. So Twitter works with the Twitter account. So you need to have a Twitter account to work with Twitter. So let's do that first. So let's say sign in. Now, when I say sign in, this is a connection which will be created. So let me say TweetCon. And then you say that authentication type, right? Use default shared application and say sign in. The moment you say sign in, the sign in screen appears, which is actually like this kind of pop up. So I'll just enter the credential over there and come back, right? Let me just authorize it. And once I have entered that, you will see that it will be reflected in the screen saying that, hey, with a green checkbox. That means this is now connected. Now let's open my Twitter account. So if you open the Twitter account, you can see that there are a couple of different kind of tweets happening. Let's pick it up like PDC conference, right? So the PDC conference is using a hashtag called PDC Conf, right? This is the hashtag it is using. And many people are posting about this PDC conference now, right? So you can see that there are tweets coming in, right? So I also have posted a couple of tweets. The tweets are coming in. So let's use this hashtag. Now I say continue. First, the connection has been made. Now I want to capture this hashtag, that's PDC Conf. And then I can actually reduce it to, let's say, 15 seconds. So every 15 seconds, this will be triggered to fetch if there is any tweet happening with this specific hashtag. Otherwise, tweets are constantly happening. So you will be able to get to it every time you run this thing. But if you filter it with a specific hashtag, then it's going to have a limited number of tweets. As a next step, now what do you want to do with this tweet, right? So once you have that tweet ready, you can think of, let's say, having some sort of activity. Maybe you want to put it into some database, right? Or maybe a big data analytics, whatever way you want to post it, right? So you want to store somewhere. Now, where do you want to store? So let's use some sort of a serverless storage mechanism to store these tweets. So if I go over here and then create a new serverless storage, let's say Cosmos DB. Now, Cosmos DB is a serverless component. Now, I can go ahead and create a Cosmos DB in that same resource group, which will take a bit longer and will basically waste few of time. What I have done is that I have already created the Cosmos DB, but I'll then create a collection inside that Cosmos DB. So collection, sort of like you think of it like a table. Okay, so I have this Cosmos DB, and what I'm going to do is that I'm going to go ahead and open this Data Explorer. And then inside the Data Explorer, you have already a database created. That's PDC 2021. That's where I was testing my code today. And then you can say new container. So new container in the concept of Cosmos DB means it table. So you think of it as a table, so where you basically will be storing all your data. So you go ahead and say container ID, all right? So you say PDC demo, okay? So you can give any name. So I gave the PDC demo. Now the partition key is the key which will basically separate your data into multiple different chunks. So let's have any kind of partition key. Let's say I say topic. Topic is, let's say, what is the hashtag I'm using. So in this case, it is a PDC Conf. So I'll consider that as a topic. So I'll store that as a topic in my Cosmos DB, right? That's all. You can see that I can just say, okay. So you can decide on the partition key based on how big the database would be, the data will be, and how you want to run your query, right? So it will be, if it grows really large, then it'll start doing a physical partition. Otherwise they will stay in the same server, right? So it only happens when there are a lot of, let's say, things happening in that, right? So what I'm going to do now, I'm going to open this thing and pick up few of the information to bring it into my Logic flow. So what I need here is now a Cosmos DB action, right? We now call it an action. What this action will do? So this action has a couple of things it can do. One of the things it can do is that it can create an updated document. So basically the Cosmos DB I'm using is a document DB, right? So which can store JSON documents. So I'm going to store my data into that JSON document, right? So that's the document DB. So I'll select this action, but there are other actions available. Now I'll have to initiate the connection. So this step, the connection is going to get created. Let's say Cosmos connection. I name it like this, and I use the access key. I have to provide the account ID. Now this time, you don't provide the fully qualified URL. Rather, you provide this name of the account, and then it asks you to provide also the key. So you have two keys, primary key and secondary key. You just use one of them. That's all right, right? Now, you might have a question. Hey, you have done a YouTube video and you shared your key. If someone takes a screenshot of that, what happens to your database? Nothing, because I'm going to regenerate the key after this demo. So you will not be able to access my Cosmos DB using the same key. So that's the solution I have. Now, if you can see over here, it can now start navigate into that Cosmos DB. So it can identify there is a database called PDC 2021, which you have seen in my Cosmos DB tab, which is the other tab. And then it also can fetch all the collections I have, right? So the PDC demo is the freshly created collection, which doesn't have any data. And I can actually add now the document. Now the format of the document would be like a JSON file. Now to bring a JSON file over here a bit difficult. So let me do one thing. Let me use a notepad to create a structure of my JSON file, right? So if I have the notepad available in front of me, and I can just say that I have this ID. So ID is a field which is mandatory over here. Either you give or it's auto-generated. So this will have a value, right? And then you have a tweet text or tweet, whatever field name you want to specify. And then you have a type, right? So type is the um, partition key, if you remember, right? So just to verify whether we are doing things correct. So you go here into this collection, go to this, browse to this collection, see what exactly the type it uses, right? So you go to the item, it's a topic, okay? It's not type, it's topic. So we'll get an error if we use this. So this is topic. Okay, and then this topic can be hard coded, right? So I can even pass it on dynamically. So I'll say PDC conf. If I use a variable, then I can pass it dynamically. But let's use this PDC conf as my kind of topic name. Now let's use this document over here. But you notice here, the ID and tweet field are empty right now at this point in time, mainly because I'm going to use this dynamic content to bring in this ID and thing. So if you put your cursor next to this ID field before the comma, then you have got a list of values which basically comes from your tweet text, right? So one of them is tweet ID. So if you see that every tweet you may post has an ID, right? Unique ID. And then for the text, I will use this placeholder, and I just search for tweet text, and you get a tweet text. Okay, so now these two are dynamic value. So every time there is a new tweet being captured by this logic app, the tweet ID and the tweet text will be part of my document, which will be finally posted into Cosmos DB. Now, one small thing you need to make over here is to say what is the header here. So the partition key value. If you don't specify, then it'll start complaining. Now, once you do that, now it asks you to provide the value. So the value should be the same as it is mentioned over here, right? So you specify the value like this, and you are done, right? Now you save it. The logic app gets saved, and if you see over here, the behind the scene, you have got all this JSON generated out of this designer activity you have done. So you have all this JSON file basically getting created, right? So you can see that PDC conf is the hashtag I'm using to fetch the trigger, and once that is fetched, I basically am creating the JSON document to post it to my Cosmos DB, right? That is the create or update document action, and that is taking ID, topic, tweet. You can even edit here. Okay. Now, if I go ahead and say run, now it will run the trigger. Now, what I wanted to do is that I wanted to run here and go into another, let's say, a tab within my browser to see this from the overview window. Now, if you see overview window has got something called run history. Okay. If you refresh it, you'll probably find some data coming in slowly after some time, right? So you can say run trigger from here as well. And once this is successfully run, if there is any new tweet, then it'll definitely show up. Now, sometimes some hashtags are not as busy as we expect, so they do not have many tweets. So if you are watching, please go ahead and tweet, and your tweet will be visible over here. So hashtag PDC conf. So we don't have any tweet, right? What I can now optionally do is that for the demo sec, I can go ahead and change the hashtag and fetch something else. So I can even say that use Azure. So I'm sure many people will be, or use some, let's say, hot discussion topic, which many people are tweeting, right? Now, if I go ahead and do that, and let's say run trigger, and then I say run trigger from here, I might see some tweet coming in, right? So you might see that you can see now that there are 3 tweets already shown up. Probably they are from Azure, right? So now if you click on one of these run history, that's the beauty of Logic App here. They can store the historical execution. So this is the older execution. And you can see that it searched for Azure. So PDC conf do not have any new tweets, so hence it couldn't find. But you can see that the body of the tweet brings in here And if you go to the next step, it basically brings in that and then massages the data into 3 of column format, right? And then it tries to save it to a document DB, Cosmos DB, and it is successful. So the green check boxes means they're successfully executed. If there is a problem, you will find that problem here. So it's a nice way to really do the debugging. So if you do the debugging, then you will get to know what exactly the problem, because you can now get inside the error messages and find out the troubles. Okay. So if you go to the run history and refresh it again, you might find few more additional things shown up over here over a period of time. So this will keep growing, right? Now you you go back into the designer of the logic app, right? And you say that now my data is in Cosmos DB. So let's see the Cosmos DB database. Okay, so this is my Cosmos DB. Now if I say over here, I say I want to load more item. So it's a query. Okay, so you can see that data is shown up. Now you have noticed that I tried to save only three column record, but there are certain auto-generated columns like underscore RID, underscore self, underscore etag, underscore attachment, underscore TS, that's timestamp. So all of them gets added by default by the Cosmos DB, right? So Cosmos DB does add these things. So this is for Cosmos DB to maintain some sort of integrity and then keep the history of the thing, right? So because it needs to do a lot of replication, etc. Now, Cosmos DB is really a large thing, right? It meant to be for a large amount of data. So you can do a lot more stuff with the Cosmos DB. So what we have used so far is a very, very small piece of it, right? And that is basically what we have done to only store data. We haven't yet retrieved the data. Now let's try to retrieve the data. Now, one of the ways to retrieve the data could be to, let's say, have have a application, web application, and display that in from our dashboard. But we can use something which is built in. Let's use Power BI. Okay, and Power BI Desktop is, by the way, free, so you don't need to pay for it. And I will not be using any paid version of the Power BI over here. So this is an installed Power BI in your local machine. So you can also install it. It's a free version. So notice this icon. So this is the new icon. So anytime you use a Power BI, if you see this icon, that means you are using the latest Power BI desktop. Okay, now you can see that. Let me just bring it into this window. Okay, you can see that the splash screen comes up, right? And it has got some help. So let me use the get data option. If you do the get data option, again, sorry, I need to bring that whole thing up. So it gives me a couple of data sources. So if I see over here, then I can have an Azure, and then I can also select, let's say, Cosmos DB, because my database right now is in Cosmos DB. Now, once that is there, what happens? It shows you the same set of information. It asks for the same set of information. Let's take this information from my keys section, copy, and this time I'm not going to just give the count name, but the fully qualified URL. Okay, and then I say that database name, right? But I copy this. So the database name is PDC 2021. Just to verify, if you go into this Data Explorer and see the PDC 2021 available, right? So that's the database it is asking. So I say PDC 2021. Collection is optional, but let's also add that collection over here. That is PDC demo. Where is that? Yeah. So PDC demo. Okay, that's a collection. Now this will ask me to enter the key. Okay, that's how they will authenticate. Otherwise, it doesn't know much about this thing, right? So I'll say now this key. It's not asking the key. Now you can see that this is not the data I would like to display in my report, right? I don't want to show record, but there, what is there? So I have an opportunity here to really transform the data. Now, when I say transform the data, what it means is that you can actually change the layout of the data, how it is displayed. Now, you see here, there's a small portion which allows me to now split them into columnar data because they are basically JSON at the end of the day. So if I get rid of this auto-generated underscore sort of field values and have only my fields, okay, and say yes, now you can see that now the data is shown up as a tabular data, right? So the tabular data is something, close and apply. And what happens now is that it's going to go ahead and get the data in my Power BI dashboard, and then I will be able to build a report out of it. So the whole idea of doing this exercise is to build something to view the data, right? So you see over here, this is my now Power BI dashboard. Now that I did query, I didn't name it properly, but query is the thing which I need to display. So if I say this and document topic and tweet, maybe I don't need topic, right? So just the tweet, that should be fine. So I will rip, and then if you just increase the capacity, you have only one of them. So if you say refresh, it's gonna go ahead and fetch the new record if there is any and show you that. So you basically are able to create a report which is coming from your backend Cosmos DB database. Currently, Cosmos DB holds only, let's say, 3 records. But if you keep running your logic app, you will have more and more record, right? So for example, if I go into my logic app and say run trigger and then run it, and if people are doing tweet about Azure, it should be having more, let's say, record. Now you can see that there are more execution happened already. So more than 3 records. So if you just check the Cosmos DB and then say run this query, you will find this. There are Cosmos DB records showing up over here. If you now go to this thing and say refresh, it's going to go ahead and fetch the record and display them over here. So it basically can be a live dashboard of what exactly happening behind the scene by the logic app, which is fetching the data into your Cosmos DB and then making it available. Now you can do a lot more things. So what I am doing is just the surface level of what exactly is happening, but I can actually change the behavior. For example, I can bring in some other serverless component also into this flow. Let's try to bring in some other component. Now, what I am planning to do over here, before I pass it on to the Cosmos DB in this flow, I want to add another step in this logic app designer. So to add a step before or after, you can add it anywhere. So there's a plus sign. And if you want to add it later, you say add it later. So if you say plus sign, so you say add an action, right? So the action is the step I mean to say. Now I have used Cosmos DB, that's what it is showing. But let's say if you want to do some sort of AI activity, you have a tweet, you want to identify what is the sentiment of the tweet, how people are reacting to, let's say, Azure. Are they positive about it? Are they posting negative comments? What is the reaction of the people, right? And a lot of marketing campaign, they do really this kind of exercise of reading the customer feedback from many different channels. So let's try to build something similar into this. So if you notice here over this thing, what I can do, I can bring in something like text analytics. Now, you might or might not know about all these connectors, right? All these component. So they are differentiated by the group, but you can always go ahead and use them from the document. So text analytics is a way to leverage Azure Cognitive API. What we use is a text analytics cognitive API, and it can actually detect the language. So if you, let's say, if it is an Indian system where people are posting to it in many different Indian languages, and you want to identify what language this is, and then filter based on that, and then probably put it in a different collection based on the language so that you can do it better analysis, right? So you can also use this cognitive API to detect the language. Now, we have a couple of other things. Now, what I wanted to use over here is a sentiment, right? So sentiment is gonna give me, let's say, certain value between 0 to 1. So it is in decimal, 0.1 to 1.0. So anything which is lower than 5 is negative. Anything which is higher than 5 is positive. In anything which is 5 is neutral. So that's how the calculation happens. Now, for that, you need a cognitive services service created somewhere, either in your subscription or outside of your subscription. So let's say I have this cognitive services kind of thing created already in my thing. So it's basically nothing but as an entry, right? So because it uses an API to do that. So what I need from this is that its key and the URL. Okay, that's it. Okay, I don't need to configure anything. I just say I need a cognitive service. So I went ahead and created a cognitive service. So it is a cognitive services endpoint. So you can see that this is the URL. And then I can just, I'm using a free version so that it doesn't cost me a lot. And I pick up this key and endpoint, right? So if I say copy this URL, come to my logic app and say the connection name, my text analytics cognitive. Okay, you can give any name. An account key is the key where you need to specify the account key. Let me first type the URL and then go back into my thing and then copy this and then I paste it and I say create. So the connection, it will be established. It's like a database connection, right? So you provide the database detail and then connection is established. Now it need to pick up a document, but you need to give the document ID a unique ID. Now let's use this previously. You can see here, you have steps, right? So all these previously extracted values will be shown here. Now, every tweet has its own ID, right? That's what they use to uniquely identify a tweet. So let's use that tweet ID because that's a unique ID because you need to provide a unique ID. So we can leverage that. Or else you can also have your own variable created before this and increment them. So you can actually, for every step, you can keep incrementing and then definitely give you a unique ID. Okay. And then what document do you want to, what text do you want to really analyze? So in this case, I want to analyze the tweet text, the text people have tweeted about, right? So I'll pick that up. And then I can also say that I want to do a language specific analysis. So if you specify a specific language, you can even use the Twitter language identification system. Twitter gives you the language name. So if you see at the bottom here, original tweet language, right? So that kind of Twitter language you will find over here. That's all, right? We don't need to really make it complex. So I picked up only tweet ID and tweet text, and I just wanted to save. I haven't really passed it on to my Cosmos DB. So let's see what exactly it shows. So if I save this thing and I say run the trigger, and I go to this other tab, and I go to this run history, and depending on the time I'm running, 5:10, this is the current time. 510, do I have a new thing? So it's successful. You can see that sentiment is getting parsed. So what was the tweet? The tweet was additional guidance regarding OMI vulnerabilities with Azure VM management extension, blah, 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 some URL, some hashtag. People are really putting a positive thing, right? So you can see that there are different parts of the sentences. So let me just pick it up from here and then use it in a better no view other than having a small thing. Okay. Some JSON. Okay. All right. So open folder. All right. A document. Da, 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 da. All right. Yes, I trust. Plus some dot JSON. Okay. Cancel. I don't need anything. I just need to read this. So there is nothing much I'm going to do here. Okay. So you can see over here. Okay. So just increase the font size. So now you see here, that's the output which the text analytics is giving me. So what it's telling me is that the sentiment is really neutral, neither positive nor negative, right? And it also has got some score, confidence scores, right? And you can actually see that it is an array. So the output is an JSON array. And within that, you have multiple sentences. So it basically try to fetch multiple, let's say, thing. But because it has only one sentence, that's fine. So it only has one output. But if you have multiple sentences separated by dots, mainly, they will split it up and give you different sentiments. So a phrase, a paragraph can contain both positive and negative. So each sentences are considered over here. So you can see that it is clearly telling the sentiment is neutral. So that's also fine. Now let me check few other stuff over here. All right. So you can just quickly see over here that this is the value. Now, you see on this screen, right? That's the text which was being read, right? Now, if I go back and let's say pick up some other value, maybe this one, and if I notice the output, learn how to automate application is again showing neutral. Okay, let me see this one. Unless somebody says great, super great. Using PowerShell to query Azure RBAC assignment. Okay, so that's also something I can copy, and let's paste it in my Visual Studio Code. Okay, so you can see that this is also giving me some sort of input, right? And you see the text, and if you really automate the whole process, you want to automate the whole process, you can automate the whole process. Not just this one. There are many different things you can do, right? So in the context of, let's say, the serverless, especially in the context of Logic App, which we are building over here, you can have many different steps. Now, I want to quickly highlight one small thing that is this one. So let me go ahead and open it up over here. Let me minimize this, and I go to the designer. Okay, and I click on the designer, which will allow me to edit that thing. Now you see that sentiment does come up with a loop, right? So I'm sorry, not loop, the collection. Now in that case, it was gonna be having a loop. So you can add a loop to do something. So you can actually make things complex, right? So if you use a control, and control says a for each, Now, that for each really says that what are the things you need to do that for each? Sentences or documents or errors or details. So this is coming from the sentiment step. Now you can see that each step has got some output. So they are basically grouped together based on the output. So if I say sentences, and then sentences are coming with another set of loops. So it can go into, let's say, loop after loop. So you can bring in more loop inside and then say control for each. And here you can see that I have got sentiment, I have got Twitter, I also have got a for each loop for the current item, for each loop for the current item. So you can literally go one after another, right? So you can say that, hey, you know what? Instead of this, I want to bring in the current item from the for each loop. And then in the second for each loop, do I need that for each loop? I can say delete. I say delete, and then I say add, and I say, do I have the loop? Then I need a loop, otherwise I don't need a loop. So what you can do, you can actually make a variable and store the value from inside that. Maybe you have multiple ratings. So you can do one thing before this step, you can add a variable, right? So you can also have a variable. If you add a variable, now what happens? This gonna go ahead and store some value. Now you can define a variable, right? You say initialize a variable. You initialize a variable score, okay? And then you can define a type, let's say string or float or whatever it is. And the value is start with 0, okay? And then inside this loop, right, for each loop, what you can do, you can actually go into that and add an action and then use this variable to increment the variable or append the variable or do something, right, or set the variable, right? So you can do that. So for example, you have a variable called score, which you just now have defined, and get the value from your step number 2 within a second for each loop. That is, you go down. So it started becoming complex. Okay, you can see that there are much more options to pick up from, right? So you can see that for each 2 current item, and I can store that value over there. So you can actually do this kind of activity and then finally get the kind of common average value of the sentiment score, and then use this variable in your this step where you are basically updating a document. So in this step, what you can now add is the score, okay, score value. And then if you say that score is something which is my variable, okay, so that's how you pick up the variable value from the previous steps you might have used. So let me just reduce this size so that you can view it properly. You see over here, you have this tweet coming in. You did a cognitive analysis to understand the kind of tweet. You ran through a variable and then build that variable by doing some complex mathematical calculation. So you can actually do a lot more expression-based calculation, right? So you can see that there are a lot of functions you can incorporate, right? So you can actually do a mathematical calculation of doing an average, etc., right? So you can the mean, max, all these things you can do. So these are all functions you can use over here. And if you want to do that, you can do that over here. And once you are ready with that variable, you just simply pass it to your Cosmos DB document creation. However, if you put this Cosmos DB document creation in the for each loop, those many number of times the document will be created, which is not right. Okay, so we can do that. So if you have a, let's say, array output coming in, you want to go through each of the element and add record for each of these elements, you can run through it and then get them all kind of posted into your document DB. So I would like to open it up for question and answer. If you have any questions, comments, and you want to clarify, please do let me know. No questions. All right. So I think we are almost at the end of the talk. So what I'm going to do is that I'm going to take you back to the screen where I have posted few links. And I would highly encourage, if you're interested, to have a learning path available in MS Learn, which is basically a concise edition of Microsoft documentation focusing towards a specific type of thing they want you to learn. And then there's a reference architecture available for scalable e-commerce web application using some of these serverless technology, and the learning challenge, which I have created custom made for you. So with this, I want to thank you for attending this beautiful event in this weekend. I wish you a happy weekend. Spend good time with your family, friend, get refreshed, come back fully energetic next week.